Everybody. Welcome to the Materials and Manufacturing Showcase. My name is Janet Geddes. I'm the Deputy Director of the Global Team at Innovate UK. And we're here this morning to tell you a little bit about the global opportunities we have within the team to help you as businesses take your first and maybe second steps in global engagement. So we've got 3 sessions this morning. We've got my colleague Ansh at 10:10 is going to be speaking about all things Horizon Europe and how that could help you as a business. I have my colleague Ben at 9:20 speaking about the Eureka opportunity. But up first, we're going to be hearing from a couple of businesses, from Nishant and from Neil, who have used and participated in a couple of our global programs. So we'll hear more about their experiences of those. Bear with me with the technology. So that's us. But first I just wanted to quickly run through a little bit about our global offer at Innovate UK. So all this information is available online. I think these slides will be circulated afterwards, and the links you can check out. But basically, we've got 2 main forms of support to help you as a business engage internationally. And we talk about engaging internationally, about going global rather than an export journey, because the support that we provide is wider than that. It's really about helping you take your first steps as an innovative UK business in going global. It's not just about the export journey. It might be that you're looking for an R&D partner in another country, or a manufacturing partner, or just want to benchmark yourself against competitors in other countries. So our first bucket is related to supporting international research and development collaboration. I mentioned Horizon Europe, and you'll hear more from Ansh on that. Ben will speak about Eureka. We also have opportunities with individual countries as well. So we have various programs, for example, with Canada, with Singapore, with Taiwan, which enable you to work with a business and research organization in those countries. We provide grant funding to enable you to do that. And we've also got a program called our Energy Catalyst for those that are working in that in the area of energy access, modern energy access. And that's working across a number of countries, and that again enables you R&D funding to take partnerships with those countries forward. And then our other bucket of support is related to helping you as a business explore a new market. You might be on an export pathway here. We've got various programs. We've got our Global Business Innovation Program, our GBIP for short, and we'll speak a bit about that now. And similarly, we've got our Global Incubator Program, which enables you more time in market. We'll hear about that. We have a new program called Global Explorers, which is a small grant funding available for you to work with a country of your choice to take forward your growth with that country. And finally, we also deliver the Enterprise Europe Network Partnerships opportunity. So that's an online portal where you can post requirements that you require from an international partner, and also respond to other requests that are up there. So that's all available online. As I said, the slides will be circulated. Just to give a flavour of the incubator program, one of the programs we'll speak about this morning, we've got a short video to play.
It's incredibly challenging to enter a new market. Having guidance of people on the ground making connections for you and helping make sure you avoid mistakes is pivotal to success of an international expansion.
The Global Incubator Programme is an acceleration programme looking to help SMEs grow and scale globally. We've supported a significant number of companies as part of this Global Incubator Programme that are looking to develop their connections and networks in Canada, working with Mars.
So we've run several of these programs with Innovate UK. It's a multi-year partnership that we're developing to run cohorts once a year for both the programs that we run with them. One is focusing on artificial intelligence, and the other is focusing on advanced manufacturing.
I was immediately drawn into this program because we wanted to work with the best, and through Innovate UK, And with the Mars Innovations help, we're able to now get into the hub of that action.
What I found with Mars is that they've been really proactive in providing us with a range of different opportunities across a load of different skill sets, from marketing, PR, strategy and AI support, which really helps us to improve as a business but also understand the Cladio ecosystem better.
By working with Mars, we've been able to have opportunities that just we never would have had coming here on our own. Things like we've been on CTV News, Front Star. This kind of exposure and building our brand here in the market has just been incredibly vital for us, because we want to be a leader in this AI governance space, and this has just been a fast track way for us to do that in the Canadian market.
So by working with Mars, you get access to seasoned entrepreneurs. You get access to our network of ventures that are operating in market as well too. So a huge peer network that you're diving into right away, but you're also tapping into our extended networks of corporate partners, government partners that make that transition so much easier.
Working in partnership with innovation hubs like Mars has enabled us to provide even more support to UK businesses. We can help them increase their R&D collaborations, networks and partnerships in Canada, accelerating their go-to-market journey.
So hopefully that brings our incubator program to life a little bit, and we're going to speak about it a bit more with Nishant and with Neil. So I'm going to introduce you both, which is always slightly cringy potentially, hearing yourselves being spoken about. But so Nishant is CEO of Value Chain Technology. He's a technology entrepreneur and supply chain innovator dedicated to transforming how manufacturing companies collaborate with their suppliers. As CEO of Value Chain Technology, Nishant helps businesses enhance supply chains efficiency, reduce risks and optimize performance through intelligent supplier collaboration software. Value Chain focuses on aerospace, automotive, electronics and food production sectors. Nishant's experience lies in leveraging and digitalization to empower manufacturing leaders with actionable insights, ensuring that they stay ahead in a rapidly evolving industrial landscape. So Nishant and Value Chain have participated in 2 of our international programs. That's our GBIP, Global Business Innovation Program, and our Incubator Program, both focused on advanced manufacturing in Singapore. And we've got Neil. Neil is a highly experienced professional in the field of non-conventional metal cutting and processing, and is CTO of Holdson. Holdson is an electrochemical polishing machine tool supplier, aiming to address the issue of inconsistent surface finishes on additive manufacturing components through innovative and sustainable technology. And Holdson is, I guess very proudly, West Yorkshire based. From 2000 to 2011, Neil specialised in developing bespoke systems for major aerospace companies across the globe, and this included contributing to the creation of the first ever 3D printed aerospace engine blade. And since 2011, Neil has been pivotal in developing new processes, products and teams within the industry, and has contributed to numerous patents, underscoring his significant contributions to this field. So Neil and Holdson have participated in our Global Incubator Program to Singapore as well, the same one that Nishant went on. Thank you. Right, over to the interesting bit now. So before we get on to the support that Innovate UK has provided you, I just wanted to roll back a bit and understand where both your businesses are now in terms of your growth journeys, and what led you to thinking about international engagement. Nishant, shall we go with you first?
So we are at a scaling stage currently, and as we are a software business, addressing supply chain issues, which is not just a UK problem but a global problem, and is sector agnostic. And when we are looking to expand, and add value where we already have customers globally, it was key for us to understand, to validate our solutions, find partners, find relevant customers globally. But that becomes a very daunting exercise when you're trying to do it on your own as a small team amongst everything else. And for that reason, we were quite active to try to look at what different programs, what different opportunities have been available in UK to support that. And that's where our journey started.
And Neil, for you?
Yeah, so similarly, we're scaling as well, being supported by the Innovate UK scale-up team at the moment. We've been on a really rapid journey from our inception to where we are now, growing really, really quickly. Because of some of the history of some of the team, myself included, we knew that the technology that we've developed and technologies that I've been involved with in the past, the uptake of that technology is far more rapid overseas. So effectively, we've created an export business, really. 90% of our inquiries are export inquiries, and we anticipate that to be the same all the way through. So we'd already gained interest from America, from a lot of countries in Europe, Germany predominantly, from the Middle East, from Greater Asia and the APAC region as well. So we'd always anticipated we needed to go overseas, but we knew how hard it was going to be. And actually, we thought Germany first, North America second, and APAC third. And the program that we were introduced to actually totally changed our minds on that as we developed new interest in particularly the APAC region, and we needed to understand how we could support those customers, and that was the purpose of what we intended from the Global Incubator program itself.
And how did you get to the prioritization of countries before you engaged with us? How did you get to thinking Germany first? What was your thought process around that?
So we knew that the technology that we've got is agnostic in terms of the manufacturing method, but we do know that additive manufacturing for metal components is, we lend ourselves really well to help the enablement of that technology for certain industries, not least aerospace, automotive, energy, and others, and particularly medical, surgical implants, etc. So we knew that wherever those sectors were growing quickly was where our technology would be used as an enablement factor. So the first thing we did was go and exhibit at the largest additive show in the world, which is in Germany. There are several of them, but the German one is by far the largest. And people were coming from Australia to see what was going on in the additive sector, from Canada, from Brazil, from all of the Americas, from all over the world. And so we'd already got, I think, about 140 qualified leads before we knew about the incubator program. And we were really shocked that the majority of them were coming from the APAC region. The reason we were shocked was we'd done some market research, and we knew that 50% of additive is in North America, about a third is Europe, the Middle East, and that region. And the smallest is the APAC region, but it's actually the fastest growing. And so we sort of flipped the thing round and said, actually, we've got to investigate this, because how are we going to support customers with our machine halfway around the world? And so, fortunately, we knew of the program, we were introduced to it, and so the rest is history for us.
Great. So it sounds like a good thing to do is potentially look at attending a big event or conference abroad as well as a first step. It gives you that exposure, makes you potentially understand where main stakeholders are and where it leads.
Absolutely. I mean, you've got to, whenever you're in business, you've got to sort of do your market research, and we understood that that was a major part of where our opportunity lay. And that's not the same for everybody, of course, but because of some of the history, we knew export opportunities were always going to be the mainstay for us. So do your market research and understand what the support looks like over there, yeah.
And Nishant, for you, what were the first steps you took in terms of thinking where you need to go and how to get there?
So before the program, we, again, from our research, we knew that US, Canada would be big markets, both from manufacturing perspective and supply chain and technology adoption rates versus how they are in Europe. But the program that we got introduced to and we had the opportunity to take part in was the GBIP program. And that was for Singapore. Now, Asia, again, we knew that there's a market opportunity for us because the technology adoption rates there are much higher. And when we got through that program, the key thing that allowed us to do that 1 week of that immersion into Singapore, a guided route, being able to attend a conference like ITAP there, gave us on the ground truth in terms of what the opportunity was, if that market was of interest to us or not. And on our own, we would have never done that, taking Singapore as a first instance. What it also did for us was it validated that the problem statements that we are seeing was not just linked to UK.
Okay, Thank you. Yeah, we'll come back. We'll come to that in a minute. I guess a more broader question for both of you, and the one that we come across quite often about, is there a right time for a UK, particularly a small business, to think about international engagement? Now, I know it's very sector specific, it's very product service specific, but do you think you could go too early, or will there always be something that you could get out of international engagement that grows your business?
So speaking from our own sector, our own experiences, I don't think there's any, you can't think soon enough about the opportunities that are overseas, one. But I think to answer the second question, you can go too early, because what you can do, and I've seen it in the past, and I've been part of something in the past whereby you've got to recognise you haven't got the bandwidth to support all of the inquiries that you might get and all of the interest that does exist overseas. So you have to have the team and the necessary wherewithal to be able to look at that market and actively engage in it properly. You can go and do a scoping exercise and understand what might be in the future, but actually, if you're going to put your product in there, market yourself well, look at active engagement and how you're going to support it, you'll never be able to stand that up if you don't have the resource behind you. So I think you can go too early in that respect, but in terms of thinking about it, certainly from the sectors we're in, unfortunately, a lot of those manufacturing sectors are overseas right now. You know, we don't like that situation. We want to bring a lot more high-value advanced manufacturing into the UK, but the reality is an awful lot of it exists overseas, and if you don't recognise that and engage with it, then you're missing a huge chunk of what your business growth can be.
Yeah, thank you. Nishant?
Yeah, so I think, yes, you can go too early, but I think the key aspect of that is, as a business, you're always trying to explore and understand where the opportunities lie for you and for growth. And until you actually do these exercises, you don't really know. So it's, it's an unknown. And the key aspect is you need to be very clear on what your goal is and what you're trying to get out of it. It's not going to be the case that you go to a new country, you're suddenly going to get customers straight away. It's not that simple. So you need to be very clear on your goals and need to make sure that you are putting in enough effort from your side, and you have your leadership team and the key people involved in that, because the amount of effort you put into that is what you're going to get out. So yes, you can go early, and as a business, you need to decide if you need to find more opportunities or you need to fix something else. But it's an exploratory exercise that you need to do, I think, in general, and go from there.
Can I just follow up on that as well? Because I think he's right. And to follow up on what I said, knowing what the opportunity looks like is a major factor. But recognising you might not have the knowledge and the skill and the local knowledge as to how to approach that market, how to deal with it, is a major reason why a lot of young SMEs fail, in my opinion. Because doing business outside of your parochial network that you might have, whether that's, you're a Yorkshire-based business, you're a London-based business, wherever you are, and if you maybe deal in one or two countries, doing business in other sectors, particularly Asia, for example, it's a very different experience. So you need to learn that, and that's what the programme itself, I think, really taught us a great deal about, how to engage with a new market, with a new geographical market. Because if you don't know that and you don't have any experience in that, it can be as much as it's very interesting, it can fall very flat on its face very early.
Yeah. So moving on to your engagement with Innovate UK's global programmes, just to ask firstly, how did you both find out about them? What was your route into? You spoke a little bit about it, but can you just tell us a bit more?
Yeah, sure. So I've been actively engaged with Innovate UK for a long time, and a lot of the delivery partners of Innovate UK, and we've been part of some of the programmes that are run. And I was aware of the programme without knowing too much of the detail, and I was actually speaking at an Innovate event, a local event in Yorkshire, when I was approached by somebody to say, look, this is something I think that your business could really benefit from. Are you aware of it? Is it something you've looked at? Can we, we've got a really good growth manager. Can we sort of help you look at this programme? And we became aware of it, applied for it, and frankly, through the programme, learnt far more than we ever thought we were going to about what I've just been speaking about, the nuances of doing business overseas and understanding the market. We knew there was one, but we didn't at all until we'd had some immersive visits really appreciate it.
Great. Nishant, what about you? How did you find out about us?
Yeah, so again, we've been engaging with Innovate Edge at the time, and from a support, and again from the different programs that we were aware of. So we got an email saying there's this opportunity in Singapore, and we thought let's apply for that, and we went through that process, and that was effectively our starting point.
Lovely. Okay, so to delve into the detail a little bit, so Nishant, you've been on both the GBIP and the incubator program, but to speak about the GBIP, can you just walk people through what went on during the GBIP?
Yeah. So the GBIP program was a 1-week immersion exercise into Singapore. But even before that, ahead of that visit, it was meeting the other companies that were part of the cohort from UK who will be going there. And doing some prep workshops, refining our pitches, making sure that everything is simple enough and easy to convey, which as a business you always need to be doing irrespective. So that was quite useful for us, and I think even before we started on our journey into Singapore, the companies that we met as a part of cohort, that already started a really good set of conversations and discussions, which really helped us as we went into Singapore. In that week where we were 3 days in ITAP, we met with some of the research bodies.
Just explain ITAP.
So ITAP is one of the manufacturing conferences, exhibition events similar to Hannover Messe in Germany, and organized by the same organizers as well. So there we had a Innovate UK stand with all the different companies, and we were able to showcase our solutions, meet customers, partners, investors as well there. So in that week's journey, you get that guided route of meeting different companies, individuals, partners, to understand again the nuances of that country, what possibilities are there, and that was quite critical for us to again trying to understand how do we actually get started here. And again, if we were on our own, just trying to arrange that week is not possible. There's a lot of back-end work that goes by the team to actually get that running smoothly.
And what did you come away with? How has this helped you and your business?
So, just from the starting point, it's helped us firstly refine what our pitch was, what we are communicating as a business generally, and from that we also learned one of the key things, especially for Singapore, is when you're there, things move really fast. When you come back, people don't respond to emails, so you need to get their WhatsApp number there. That's one of the things that you would not think about in UK. But these are nuances that actually make things move. The other aspects for us, again, we're trying to understand where there is a fit for us as a business and where there isn't. And that's also key to understand, especially part of the GBIP program. It was good for us to be part of that program, which was a week's worth before we actually got in and applied for the incubator program, which was a much longer program and required a lot more commitment from us as a business. So we had to be really sure that yes, that destination is something that's going to drive value for us. And I don't think that that's normally always how each program is set up, that everybody gets a GBIP and then incubator. But we were one of the few companies who had the opportunity to fit that within a timeline.
Great. And Neil, for you, can you walk us through your experience of the incubator program a bit more, please?
Yeah, so when we applied, we were asked what our interest was in the region, why it was such. Were we looking for growth there? We were looking for investment? We were looking for just to explore the market? And the answer really was kind of all of them, but we didn't define it very well, and we were taught throughout certainly the first immersive visit and then the support sessions through the summer, how to define our value proposition well within that sector, how to, as Nishant says, do business with people, what the expectations are of local people. Throughout that journey, we sort of, in the background, were growing very quickly and needed to raise money. That wasn't the initial reason that we went. It was more about market exploration. But actually we said, yeah, we need a Series A raise, and so we were working very closely with both the Innovate UK team and also the SDTTA, the Singapore Deep Tech Alliance, sort of in-region team, on how we could proposition ourselves well within Asia for the investors that are actually there. You get to meet far more investors than you would within England, or certainly within the UK. The conversations are easier to have, in actual fact, in our experience. So we were kind of walked through that process, introduced to many people, be it potential customers, potential agents, distributors, not only within Singapore itself, but the wider region, research bodies, universities. We've got a technology that's actually been the uptake is with universities and academics first, because they then work with OEMs and tier 1 suppliers to get that into the industrial network. So we were introduced to many opportunities, some of which have borne fruit already, some of which are well in the pipeline to do so next year. And then the second visit, which was when it coincided with ITAP, which is the transformational Asia Pacific show about hardware, software, and sort of new tech. We were given the opportunity to showcase our solution. We met with lots and lots of potential customers. The Deputy Prime Minister of Singapore showed an interest as well in all of the cohort and how he could help us. They're equivalent to the high-value catapults that they've got out there, and the engagement in that doesn't stop. It keeps on going and keeps on going. We learned that Singapore itself is a very well-connected, pretty small region, but that influences an awful lot of people. I learned a fantastic stat, which I think about every day, that within a 5-hour plane ride of Singapore, half the world's population lives and works. And that's going back to is that a potential market for me? If it isn't, it should be. And it's growing all the time. And then the upshot was that as we were on the investment journey in particular, we've come away from that program with a commitment, a pretty significant 6-figure commitment from a Singaporean investor as well. And also a more defined investment proposition that is now global rather than simply in the UK as well.
Congratulations. Nishant, we spoke a little bit before, and we've seen this a lot about let's say the side benefits of a GBIP in particular. Maybe it's the same for incubator program, but they're aimed obviously about supporting businesses to engage internationally, but you end up, because you're going out with other UK businesses, that quite often you actually form new connections with your UK counterparts. Can you just tell us a bit about that?
Yeah, absolutely. I think that was one aspect that we weren't expecting going into the program, both from especially from the GBIP initially, because that was the first one. But that was also true for the incubator program where Neil and I met as well. So that definitely was one of the first positive outcomes you could already derive, because you have businesses in more or less similar position to yourselves, which are non-competitive in most ways. So people are able to actually share, the things that they've done, things that they have experience on, and that drives a good, the bonding size, but also the collaboration opportunities. And that was also one thing that the program helped us tap into. That while we are there to not just look out for ourselves, but also support each other. So if we met somebody who might not be relevant for us, but somebody else, signpost them to that. So all of that was really useful. And what we have come out from that is, both from GWIP and the incubator, we have come out with cohort members who have now turned into customers, partners. Also, we have done Innovate UK grants together now. So there's an upside which, normally you're not meeting these other businesses on your own while you're in UK, because everybody's busy what they're doing. But through this program, you actually, get, balanced out. And it's not by accident, which I've been told by the team. They specifically recruit cohort companies that would be complementary to each other. And that again, is a really good exercise, which definitely helps businesses.
Is that your experience too?
It is, but both on this, and I was part of something. We went to Turkey in 2019, and I had to travel so many thousands of miles to meet somebody that was 30 miles away from our front door, and we did an awful lot of collaboration with subsequently, and I'm sure this will be the case now. Although it's not a primary focus at all, it's demonstrable, I think, of the fact that all of the cohort that are involved, and I'm sure most of the innovative businesses that Innovate UK work with, we all are collaborators, we're innovators, and we want to work together in order to advance the technology, whatever that technology may be, and grow our each individual businesses. And Nish is right, that the more that you go on these programs and you do engage with people, you start to become a bit more of a team and bond together, and you do look out for each other. And that's testament to the people, I think, and the training team that does educate those people. And that's not just in the UK, that does exist overseas, but it's a great sort of it's a great thing to be a part of.
Yeah, there's still WhatsApp groups from GBIPs 3 years ago, still very vibrant. I'm part of some of them. It is, I think it was so difficult to try and replicate that within the UK, obviously because you're taking businesses out of their day-to-day, and the social time that you have together is really impactful. So just to think then, any advice to businesses who might be thinking about going global, where to start, how to go about it, how to engage with Innovate's programs?
Yeah, pretty standard advice really. You've got to engage. It's a bit of a Blairite, but engagement would be my advice. And that's right from the very local level, understanding what programs exist to be able to help you, and then into that sort of more regional level, and then the Innovate UK Edge, as was. I don't know what it's called now. I know it has changed.
Business Connect.
Business Connect. Apologies.
Business Growth.
Business Growth. Apologies
Business
for
growth.
all of us on the stage. So it's to really engage and build relationships with people that can help you. They're there to help you. Build those relationships, because there are peripheral benefits that nobody really talks about, but that do exist. And I'll give you one very specific example. While we were on this journey, we were encouraged. We'd never heard of a program called Slingshot, which is Asia's largest pitching competition for SMEs. We were encouraged to apply for Slingshot by the team, Kevin in particular, and his partner in Singapore, Rebecca, to apply for it. And we applied for it, and cutting a very long story short, we were category winners in October in Singapore. There were, I think, 5,500 applicants. We got down to the last 10. And on the back of that, we got a 50,000 Sing dollar grant from the Enterprise Singapore, the equivalent to Innovate UK here, to grow the business out there and to look at exploitation opportunities. So we would have never, ever have even learned about that if we hadn't built that relationship with the Innovate UK advisors and the growth team, and then been on that journey. So I'd advise anybody to do exactly the same thing.
Yeah, same. I think there's so many programs and opportunities available to support businesses, and at no cost apart from your time that you need to dedicate towards that. So I think it's critical to try to connect and leverage those resources. And as you start to do that, you start to and again try to take the opportunity to go in for these programs where possible. Now these. It's not just as easy that you apply and you get in. It is a competitive program, so you need to make sure that your applications have you're putting in all the details that are required. And to get into these programs, once you're in, you need to make sure that you're putting in your time and effort into that to get the most out of it. If you don't do that, then you can't expect results. And I think for us, that's been key, because once we did the GBIP and we went into the incubator program, we actually committed more resources apart from what was already funding from the program to actually go in, which has actually driven results for us.
Excellent. Okay, well, thank you very much both. I think we've got a few minutes for any questions that people might have. No questions? I don't know if none online. Not sure we're able to see those. None. All right, well, again, please join me in thanking Nishant and Neil this morning. Thanks for coming early to the session. So we've got, I think, 5 minutes, and then we have our session on Eureka, led by my colleague Ben Morris. Thank you.
Good morning, everybody. Thanks for joining this session. This leads on from Janet's session about international opportunities, and I'll be going through some of the programs that I look after from a point of view at Innovate UK. So my name is Ben Morris. I'm the program manager for Eureka. It is a program of 48 countries that are in the association, so it's a wide, far-reaching network of opportunities that happen. And with us, we've got Rachel Eggington, the Chief Operating Officer for Q5D, who's been on a GBIP to Singapore. And we've also got Stephen Carl Henney, who's the Managing Director of Tissix Metals Composites, and they're based in Farnborough. And he's had a smart cluster program project, which I'll go through in terms of the opportunities that sit within Eureka. And we'll have some questions and answers at the end if you want to know about the program. As I said, so Eureka is an association based in Brussels. The UK is a member of it. There are 48 countries that sit within Eureka, geographically centered around Europe, but also including far-reaching countries such as Canada, Chile, Singapore, South Korea, Brazil, Argentina, and South Korea and South Africa. So you can see it reaches globally in terms of participation around the network. So I've got plenty of slides. Don't worry about that. The slides will be shared at the end of the day. And I'll briefly go over some of these because they've already been mentioned by Janet, and these sessions are being recorded, so you can always refer back to them. So Innovate UK's mission is really scaling up businesses, helping them grow, exploit, get all to commercialization, all those great things that we were aiming to do. We sit as one of those 9 councils that you saw on the screen there. We're the business side of it, whereas the other sections of the organisation are from the academic and research organisations type organisation. In terms of presence of where we sit, you can see that Innovate UK, we're based in Swindon, and these are all the other accessible organisations that sit with us. So we've got Business Growth and Business Connect, which are 2 of our sister organisations that help us do what we do at Innovate UK. We've got the Catapult systems, and we've got the Agritech centres, which are similar to the Catapult network. In terms of where we sit in the global team, on our plan for action, we sit in the middle pillar of that, going global. And then you can see the strategy or the strong foundations of where we are aiming our participation in innovative activities. So I won't labour on all these slides, but you can see from a point of view of where we're focusing our attention, clearly AI has come out since we created these slides, so that'll be another thing that's added to this pile of opportunities that we are focusing our attention on. But certainly from a point of view, you can see it reaches all the main challenges that the government sets as priorities. In terms of where we sit, obviously we've got grants, funding and support. I won't labour on this, but I'll go into the slide after, which you can see where the opportunities sit. As I mentioned, the catapults are part of our organisation, that's where they sit. So why we do international is important. So you can see those points there, and ultimately it's about creating jobs, the growth and the stronger supply chains in what we want to do by scaling up the businesses and those organisations that participate in activities that sit around the global team. It still works domestically as well, but focusing attention on where we are with international opportunities, the programme I look after that, the Eureka, fosters that ability so you can have access to those markets, the knowledge sharing in other countries where you would not possibly, or you've already got it on your radar where you want to work with. So going global, as I mentioned, you can see from the points on there, the sort of the competitiveness about it all is, having those, as I mentioned, those access to those markets, getting your foot in the door in those countries so you can scale and grow, not just domestically, but overseas. So in terms of investment over our plan, we've got up until this year. Obviously, a new plan will come out later the year. Investing in from a point of view of those opportunities. Collaborating with over 20 countries, you can see we've got a far-reaching network of businesses that we're collaborating with overseas, not just businesses, but also research organisations participate in the bilaterals and the multilaterals that we undertake. And in terms of products, the green area really is where I sit in terms of what happens. You can see that we've got the access to the innovation and knowledge through partnerships, the collaborative R&D programs, bilaterals, Eureka, and access to Horizon Europe. And my colleague Anch will go into Horizon Europe after that. Incidentally, I'm also the national contact point for the European Institute of Innovation and Technology, which is a Horizon Europe program, but Anch will mention that in his presentation. So if you do have questions on EIT after, let me know and I can talk to you through that. So in terms of the products and services that we offer, that big slide with all the lots of circles on kind of, this is the narrative of it. And I sit in the end column there, as you can see, in terms of the bilateral and the collaborative research and developments that are overseas. And it includes the GBIPs and all other opportunities that come through within there. And as I say, as part of our tripartite organisation, we've got Business Connect and we've got Business Growth. And they really are there to sort of uphold what we're trying to do in terms of those opportunities internationally. So the business growth team will do the scale up and the access to finance type activities, and then the business connect team, well, they're the team that offer the GBIPs and facilitate that on our behalf. So going to the nuts and bolts of what we're doing in terms of the program of Eureka, these are the funding streams that sit within Eureka. And obviously the piece that we're interested in today is the cluster part, which is the advanced manufacturing cluster called SMART, which I'll go into a bit more detail. But just to give you a flavour of what we offer in terms of opportunities within Eureka, these programmes are all open to UK participation. Now we're associated to Horizon Europe. Previously, the bottom two on there that you can see, we weren't able to do so because the funding came direct from the European Commission into Eureka, and we weren't able to participate. So Eurostars is one of the flagship programs, and the clusters the other flagship program. So in terms of participation in Eurostars, 37 countries within the 48 countries participate in the Eurostars program. The great thing about Eurostars is it's a centralized application process. The evaluations and the applications are all done centrally in Brussels. And then what happens is once the successful projects have been announced, you then come back to the national funding bodies and we pay for the UK's participation in that program. So the money is not coming from Central Europe, it comes from each national funding body. The last competition that we had closed in September last year, there is one that's open now. However, we don't have budget for it, but you may still participate, but self-fund your participation if you want to carry on. We still don't know what our budgets are currently for the forthcoming year, but we're hoping to allocation of funding to Call 9, which is due to open in July. And the key thing on there is it says that it's non-sector specific. So where the clusters are thematic, Eurostars is open in theme, so it means that you can come into a consortium, take it from the bottom up, design how your consortium wants to look like and the scope of the actual project that you want to do within the eligibility criteria of Eureka. So each national funding body will have its own local criteria, but the 7 criteria that sit within Eureka are these. 2 that I always point out to businesses when they're applying, because the UK only funds the SMEs in that. As I said, the programs are open to everyone, but certain programs are only funded to certain entities. So the 2 key points on this slide is that because Eurostars is a dedicated SME program, it's designed to support the SMEs and get them to the majority of the work. So if you've got a consortium, say you've got a cost of €1 million in that consortium, at least 500,000 euros must come from the SME participation. So if you've got more academic participation or research organisation, be careful, because it means that you would be ruled out because you're not having at least 50% of the participation by the SME community. And the other one on there is no one country can have more than 70% of the costs, and no one partner can have more than 70% of the costs. So they're the criteria for Eurostars. In terms of UK eligibility, we offer a grant of up to €360,000 per project. And in terms of participation, you can see that we want to make it, let's say it's research and development orientated, so you can see 10% of your time or turnover is invested in research and development. And then the criteria for the links will go to the Eurostars page where you can see more information. But my details are at the end, so if you do have any questions, do contact me or ask in the Q&A session. So global stars and network projects, essentially they are the same thing. As I mentioned, a network project, as I mentioned, the network has 48 countries sitting within the network. And if we wanted to do a bilateral or multilateral within ourselves, that's classed as a network project because we're self-governing and we're putting the project between ourselves. However, if we want to do a project that sits outside of the 48 countries, such as Japan, they're not in the network. There was a Japan call that was open last year, so that's classed as a global stars project. It's exactly the same in the way it really works in terms of the scope and the participation, etc. It's just that we're encouraging countries that aren't in the network to participate. And it's really like a show and tell on behalf of Eureka to see how it looks. And actually at the end of it, if a country will do 2 or 3 years worth of funding as a global stars project, they may want to join the network. And that's happened with Chile and Brazil and Singapore and South Korea. They did the global stars projects. They thought, yeah, this is a really good network. We'll join it. And we're trying to encourage Japan to do the same. Again, they can be open in theme. Sometimes they are thematic. We did a quantum technologies call, which was run by Denmark last year. I think there was about 15 countries that participated in that. So it's really a pay-as-you-play type activity in terms of network and where budgets lie and what the priorities of your countries are in terms of participating in the network projects. And the same for global stars. So the meat of this obviously is the clusters. This is about advanced manufacturing, materials, etc. So the clusters are industry-led communities. They are thematic in 5 key areas. Again, we can make them bottom up in terms of the consortia, market-orientated to those thematic areas. In terms of the subjects that you've got the 5 clusters there. Celtic Next, which is all about next-gen communications, 5G, 6G technology. Eurogia, low-carbon technologies. ITF4 is all about software innovation and developing the platforms in those areas. Smart, which is the advanced manufacturing and materials technologies cluster. And the last one there is electronic components and systems, XECS. So you can see there's 5 broad subjects of where you can potentially participate and create collaborations and consortia in those areas. So in terms of eligibility and scope for UK's participation, depending on the cluster really depends on how much we're putting into it. So for example, the XECS cluster will put in 500,000, Eurogia will put in 500,000 as a potential grant, whereas ITEA we put in £750,000 as a potential grant. It kind of relates back to a normal Innovate UK domestic grant in terms of the intervention rates, 70 for a small, 60 for a medium, 50 for a large, and then 30% of academic participation. The only slight difference in the academic and research participation with the clusters is there is a slight difference in terms of the 30% rule. Domestically, if you apply for an Innovate UK grant domestically, the research participation can come in at 30% of the total UK business costs, total UK project costs. In the clusters, it's slightly less, and be careful if you do have academic participation in your cluster consortium, it's 30% of the total UK business costs. So it's slightly less than the normal 30% of the total UK costs. These are the links to the clusters in terms of where they are, so you can go and see what they're all about, and I'm happy to answer questions on all of the clusters. Clearly, we're here to talk about materials and manufacturing, but in terms of what they do and where they work and all those other things, I'm happy to take questions. We don't have long, so it's a bit of a rush through the presentations. The last 2 offerings within Eureka are Innovate. These are a €60,000 grant that goes to a business. There is a match funding element. You have to put in 25,000 yourself. But it's there to do market feasibility studies in potential countries where you see access to your innovation would be a good thing. So, for example, we've just had the latest results come out of the 1 call per year majority of the actual applications, they want to go to the USA to see where their potential innovation can grow and scale up. But essentially, it's, again, open in scope in terms of what you want to do. It's down to you as a business of what country you want to go to. The first call that we did, we focused on the African continent. We're trying to encourage Africa to join the network, or the countries in Africa to join the network, and participate in potential innovative ideas in there. So essentially, it's open. You can go to any country you want to, study, do a feasibility study for 6 months, and then you potentially would come into a Eurostars grant after, because you've done your market feasibility study. And then the last one really is kind of an access to finance type activities. A country may volunteer their services to say, look, we've got this showcase event that's going on. We had one in Singapore last year called Switch. The Singaporeans 100% funded that program, so businesses applied in, they got their finances covered by the Singaporean enterprise agency, and businesses went out there to do those access to the markets in it. And these are pretty similar to what a GBIP is in reality. So if you've done a GBIP, this is what this type of activity covers. The UK, we don't have funding for it, so any business that does apply into it would have to self-fund unless it was covered by the agency that was running the event. So please read the information on those grants, and they're available. Those are my details. So there's a quick canter through the opportunities that sit within Eureka, because obviously we've got other speakers. But please do contact me if you've got any questions on Eureka. Obviously we're here, I'm here most of the day, so please approach me. That's not a problem. And I can take you through Eureka and EIT if you're interested. I won't go through these slides because these are the EIT slides. But essentially EIT has 9 global challenges that covers anything from manufacturing to food and to health and to digital. So, but these are some of the opportunities that we had within EIT. And that's no longer working, that QR code. That's it from me. I shall pass you on to Rachel.
Hi, good morning, everybody. Thanks very much for the introduction there, Ben. So it's great to be here with you all today and to tell you a little bit about the journey that Q5D have been on our Eureka Global Stars Taiwan Digital Industries Collaboration. It's a bit of a mouthful, really. So you can see a little photo of some of the team that we had as we started this project. And it started a good few years ago now. And it really helped us as an industry work alongside catapult centres and Taiwanese partners to push printed electronics into a new era. It's been a journey that's been technically challenging. It's also been impacted by global politics and the ability to move between the two countries. But through the whole process, it's been hugely rewarding. Must have gone on to a few more slides there. Sorry about that. So where did we start and why did we apply for the Eureka grant in the first place? Most of the people may know Q5D for our wiring harness technology, where we have robotics that allow you to put wires directly into the surface of product, making functional integrated products. Now, what people don't necessarily know is that alongside this, we've always had a huge interest in expanding our technology to allow us to do printed electronics directly onto the surface of products as well. And we've looked at this in various different ways, and we've always found that actually what we needed to do is build up our expertise in that area, but also really understand that market even further. And what we found is that as we looked, there's this growing need for large volume printed electronics on very complex surfaces, often with a completely 3D nature. Now, this could be, if you think a full car touchscreen dashboard, or it could be large radome antenna, frequently selective shielding, and things like very shaped PCBs that can fit inside strange products. What is out there today are a variety of technologies that can create printed electronics, but they often do it in a very 2D way, or if they can do 3D, it's for small amounts of flexibility. And there isn't anything out there that can do large volume 3D printed electronics, and certainly not at a price that's affordable or in a way that's commercially viable. So we decided to focus our interest and our innovation on trying to solve that challenge using some of the technologies that at Q5D we had and building on with some partners. Skipping two slides. So we first of all needed to build the partnerships that help us on our journey. Q5D, our experience is in large volume robotics, where we've got some really high flexibility and a lot of process development. We've had some long-term relationship with the Manufacturing Technology Centre in Coventry. And so they were the first people that we turned to when we were thinking about doing a Eureka grant to see what they could help with on that process. They have some great laser processing expertise, and we knew that that would be a key part of the technology platform we were looking for. They also have a fantastic address book. So they could start looking into that and say, okay, who could we help Q5D link to as a partner out in Taiwan? And so they introduced us through to two companies. A1, which do wireless networks, and they're a leading innovator in the space in Taiwan, and ITRI, which is a technical research institute and one of the prime groups in Taiwan looking at materials development. So A1 enabled us to have a clear end product, a company that wanted to design and develop a new style of antenna and had visions about how that might be achieved, but there wasn't a technology out there that would let them do that today. ITRI has deep materials manufacturing understanding, and particularly around metallization processes. So once we kind of got that group formed, it was a case of being able to put together that application and submit it through to the Eureka platform. Now, sounds quite simple. Those of you that have put in grants know that that is, even at that stage, a great deal of work put across multiple sectors of working in terms of getting finances in place, the strategic process that we wanted to do, some of those scoping exercises, and also making sure that it was then put across in a way that the assessing authority would be able to understand what project we were wanting to achieve. We were happily very successful, and that really is the point when the hard work starts on any of these grant-funded projects. As soon as you hear you've got the funding, it's usually quite a quick turnaround to get rolling. So as a consortium, you really need to make the best progress as you can at the start. And it's fair to say that at the start of this project, the technology readiness level was really very early. So at that point, we had some great ideas, some concepts. We had a team that were highly innovative and creative, and were used to kind of delivering technology through the different levels of maturity. It's often the case that when you do these sorts of projects, you start with a lot of ideas, and quite quickly you find that not all of them come to fruition. And for us, it was actually quite interesting because the materials processing technique that we had identified and spelt out in our application, quite quickly we realized that the material that ITRI had developed lent itself to a much more simple technique that was going to be much more commercially viable. So we had to, as a group, really look together about, do we want to make this switch to a slightly different technique, a slightly different scope, and work with the Innovate UK and Eureka team to make sure that that was going to be okay as we move through. And that was a really unlocking moment for us as a consortium. But I must say, one of the real challenges when dealing across these sort of different time zone projects is that communication piece between the different partners. You know, either waking up early or trying to have calls late in the night, discussing quite technical concepts sometimes with language barriers that is hard to then get things across. And during this period, we'd hoped to be able to go out to Taiwan, spend time with ITRI and A1, deepen those relationships, but also see firsthand some of the things that they were doing so that it would help inform the project. But unfortunately, with the sort of changing political situation, that really wasn't something that we could do through that project duration. So we had to really lean into Teams, emails, as many electronic communication, trying to keep up that flow through the project. Once we'd got that core technique in place, Q5D's role was to develop the equipment and the technology. The MTC was refining that early process, and ITRI was continuing to develop the materials and send parts of that over to us in the UK so that we could start to test out and actually evaluate the material sets that they were providing. And alongside that, AWAN was continuing to develop the antenna technology that we would finally be able to put in place. So hopefully the video will play. So at the end of the project, we were able to demonstrate the platform technology where we had created the laser processing head, the ability to have the materials. In this instance, we're just marking up a business card as a demonstrator showcase. But you can see at the bottom here, we've got the design from AWAN for antenna. That's an antenna that sits in a laptop, allows you to use your Wi-Fi. And then the actual manufactured part that had been through the different process steps on the machine at the Q5D, and then actually going through the materials processing steps with the MTC, and all using the ITRI materials. There were a few points in the project where we had to really lean on each other, because often the time when you turn a machine on for the first time, use a material, ship a material across the world and having it sitting in storage, and then when you open the bottle and it doesn't quite flow in the same way as you're expecting it. These things only come to light as you're working through the steps of the project. And what we found is that we had excellent support across the team, but also from our Innovate UK leads, that when we needed a bit of advice about how we could handle certain situations, they were always there to be able to guide us through towards the next steps of what we needed to do. So at the end of the project, ITRI were actually able to travel over to Taiwan to see Q5D, to look at the technology. And the nice thing, they kind of went back saying, could we have a quote for that machine? So from our point of view, it was one of those really unique experiences where we could integrate the best from different countries and from different sectors to be able to deliver technology that really is truly world-beating. It allows us to do large volume printed electronics with super fine and high accuracy. Possibly the most exciting thing for me was the enduring partnerships that we created, working more deeply with the MTC, working with ITRI and AWAN. We're already looking at the next projects that we can work on together. We're already starting to share technology so that we can actually be our own first customers when we're talking about printed electronics. And ultimately, what we've managed to do through the Eureka program is be able to bring a new product to market that enables a whole world of printed electronics that really wasn't possible before. A bit as Ben said, it's sort of a whistle-stop tour today, really giving you a flavour of the exciting opportunities that Eureka program can offer to SMEs who are going through their startup scale-up journey. I'll be around today. Should be able to spot me in the bright orange. We'll look usually by the coffee station. But equally, if you don't manage to get hold of me today and you'd like to chat a little bit more either about the grant-funded programs, Eureka or Q5D and what it is that we're doing, that's my LinkedIn QR code up there. So do get in touch and we can have a chat. Thank you.
Thank you, Rachel. Very interesting to see the process of how it all works in terms of getting it all together and getting projects out there, and the time zone difference. I know that because obviously we've got Canada in the network in the east and we've got South Korea in the west. Oh, sorry, east and west, get them right the right way. So yeah, we know the complications that it takes when you're trying to do long distance project management. I'd now like to introduce you to Stephen Carl-Henny from Tisix, a composites manufacturing company, or metal composites manufacturing.
Right, good morning. Stephen Carl-Henny, Managing Director of Tisix. Anyone who's met me before will know that I always come with lumps of metal, so do come and catch me later if you're interested. We are delivering lightweight net zero technologies using metal matrix composites. So we use ceramic fibres in aluminium or titanium. There we go. Our project, our Eureka project, was primarily with the UK group, but also with an international group in Sweden, Denmark and Canada. to look at machining hard-to-machine materials. So our materials are very difficult to machine. I'll come on to that. So the team in the UK were University of Nottingham, and if you ever need any machining support, go see them. They are really, really clever guys. Really, really good. Optech Systems, looking at laser systems and robotics. Again, really, really innovative, small company based in Oxford. Really clever, very, very good at integrating laser systems into robotic systems and manufacturing systems. If you get a chance to go around and see what they do, brilliant. I'm always impressed when I get to go and see other people's sites as to quite what's going on in the UK. Seco UK. So Seco make cutting bits. There's some really, really clever technology in cutting bits. I mean, it looks to anyone who's from the outside that machining and cutting is quite standard. It's been going on for many, many years. What they're doing, I had the opportunity to visit their factory in Sweden, and just amazingly clever stuff going on, and really important to what we're trying to do with this technology. And Attenborough Dental Laboratories. So an odd company to add into this mix, and we've got us with high-strength, lightweight materials in aerospace and a dental company. But really, really interesting what they did, and showed at the back end of the project some innovation, some exploitation opportunity we really hadn't expected at the start of the program. So very, very good. I won't go through all of them, but the full list of companies or organisations involved in the EU program, in the Eureka program. So it is fully sort of transnational and really good. And we were caught in the same way that we'd expected to get out and travel to see everyone. COVID kind of kiboshed that quite neatly, so we didn't get that travel side to do the networking. But we did do an awful lot of Teams meetings to meet up with these people. And again, really useful to have that international linkage. So the problem for us is we make really, really neat, lightweight, net-shaped materials and components. So robot arm, ceramic fibre reinforced titanium in the main section, incredibly strong. So this little tube here weighs about 35 grams. It'll carry 5 metric tons. So that is 2 Range Rovers, 2 Indian elephants, 1 African elephant. Very strong, very stiff, great for aerospace, great for space systems. But it has silicon carbide fibre in it. A lot of cutting equipment, silicon carbide. So you try and do anything with silicon carbide in machining, you machine away the machine tool fast and you machine away the part you're trying to machine. So we have not done very much with this for many, many years. Nottingham University came and spoke to us and said, we think we've got a solution. I was, it has to be said, slightly sceptical, but willing to give it a go because we need a solution. So lots of little fibres embedded in metal, so difficult enough on its own because you've got to change from a relatively soft metal to a very hard ceramic. And I say relatively soft because it's titanium to start with. So lots and lots of challenges. What Nottingham were able to do is to develop a system where they heated the material ahead of the cutting bit. And that softened the material enough to get to allow it to cut. And I'll come into each of the partners and what they contributed. Not a trivial thing to do because you've got to keep the heat right. You don't want to put too much heat in. You don't want to put too little heat in. You want a feedback loop to see what the temperature is. So that's, Nottingham did a lot of work to get that rate of heating, modelling how the rate of heating allowed them to get the machining done. This, I didn't risk the video, but there is a good video to go with this, showing how that heating as they're machining go through, and lots of problems with the cutting bits. So the cutting bits will behave differently because they're hitting a hot and cold material and hard and soft material. So a lot of work with Seco to get the very, very best polycrystalline ceramics to give you a very sharp, very wear-resistant cutting tool. Then Optech systems. So it's all well and good doing something in a lab where you've got an old mill and a laser and you can make it work. But what Optech did was to look at how would you make that into a safe cell, because suddenly you've got a machine tool that you can't have someone peering into because you've got a lot of laser light on there. So they developed a system to allow the robotics for the lasers and a safe cell for working. The Attenborough Dental Laboratories were setting up systems to do the thermal monitoring. Okay, so look at both the heat coming off, mapping the heat, and then using that as part of the feedback loop. Now, we thought of this as quite interesting because a lot of dental stuff is ceramics, but what they actually found is that heat monitoring allowed them to look at some of their really, really soft mold tools, which if you machine will distort, and obviously the machined part that goes to make a dental fixture needs to be the right shape for a mouth. So what they found was they could control how cold they were machining something, so they didn't distort the parts while they're making it. Not what we were expecting, but really useful out of the back end of it. So that consortium managed to deliver a system that is the first time in 30-something years working on metal matrix composites I've ever seen any machine a surface that looked like a polish finish. Really, really good, and a great outcome from the program in terms of our interaction with the various people. Why is that important? Well, we're looking at lightweight materials to reduce emissions. We've got a material that's twice the specific performance of other metals. So chance to take 50% out of aircraft parts. So it's really important to the UK, really important to the globe. We've made some big parts. So this part here is about 1.5 meters long. Half the weight of the steel part it replaces, 50% stronger than the steel part it replaces. It's capable of repaying itself on an aircraft inside 2 years with fuel savings alone. And it doesn't matter what aircraft, it doesn't matter whether it's sustainable aviation fuels, fossil fuels or hydrogen, it'll work on all of those. That technology in aerospace could save 9 million tonnes of CO2 a year. Huge, huge benefit. Only if we can make parts. Manufacturing is critical. And that's where this helps. And what we're looking to do is build a global capability of that. And with the partnerships we built within Eureka, that's a lot easier. Thank you. Sorry, a bit too long.
Thanks very much, and really interesting to hear your stories about the Eureka project and obviously the missions that we're doing. We've got 5 minutes now for questions and answers, so if anyone's got a question about anything, whether it's participation in the actual program or questions about Eureka, happy to answer questions. If you just hang on, because the audience online wants to hear what you have to say.
Thank you very much. Very interesting presentations. My name is Mario Cordero. I'm the Director of Innovation in Welding Alloys Group. We have been quite active in Innovate UK and Horizon programs, but we come from heavy engineering sector in the metals industry. My question to you is, the Horizon Innovate UK, do you think they are heavily biased into really, really novel applications, or is there still a place for more traditional sectors like the heavy engineering, where I come from, where there is still a lot of innovation, but in my opinion is slightly oversight. You know, despite multiple attempts, we have been unable to get the benefits of programs like this. So any comments you might make about that, please?
Certainly. I mean, from an Innovate organizational point of view, you're probably right, the bias is there. I mean, we still have big programs, managed programs in the aerospace industry and the automotive industry where potentially that could fit in. You know, the ATI and the APC programs that we have certainly would fit around what you're doing. And then going back to the smart Eureka cluster with the advanced manufacturing processes, they can also support what you're trying to achieve. What I say to businesses, actually the 5 clusters that I mentioned, I know that innovators can be sometimes a bit blinkered in their own innovation. It's your baby, you want to create it, you want to scale it and grow it. But I give the example of if you look at the low carbon technologies cluster, say for example, you're designing a new blade for a wind farm, well, actually, that design of that blade for the wind farm is an advanced manufacturing process. So it could sit in the smart cluster. Also, once you bolt that blade to the stanchion that sits offshore, there's a box of tricks that sits on top of that, and it covers electronic components, the systems, it covers communications, and it covers software. So in reality, what you're trying to achieve, in my view, from a point of view of what you're doing, you could come into the cluster program and probably potentially scale up what you need to do in the manufacturing process. From these guys' experience in terms of their access to it, I'm not sure. Have you got any comments on that?
Happy to add. So I think from the experience that I've had, a lot of it comes down to building the consortium that is also very broad in terms of what it brings to the program. And I think this is where the innovation within more established and perhaps more traditional industries actually maybe bringing in partners that are on an earlier stage in the journey can make that look like a more well-rounded consortium to the assessors. I always liken a lot of these applications, it's a bit like doing a school exam. You have to not only have the amazing concept and the great group around you, but you've got to understand what it is that those assessors are looking at and what gives them confidence that this will hit all the requirements of the programme, but also will be one of those few projects that actually end up being hugely successful and driving the UK forwards. And sometimes by putting together that group around you can actually help with that confidence building. And we've certainly found it with the different grants that we've put in very different areas, not just Eureka, but other areas across the Innovate UK grant system, is the ones that score more highly are the ones where we do have that really diverse group working on a project together. Don't know if that helps.
Coming from potentially a heavy industry or lightweight, but hard tech manufacturing, a lot of what we've seen, and we've had huge support from Innovate UK, ATI, Horizon, you name it, we've been through all of those, and they are really, really helpful to help grow a company. Sometimes, and if you look at the technology you're trying to develop, there are things that you take for granted as being, well, that's kind of, we know what we would do. That's real innovation that you've got to get across. I think I take up. It's explaining it in a way that someone who hasn't been doing it for 20 years, 10 years, 30 years, whatever, understands what you're trying to achieve, because it is real innovation. And if it moves your business and your technology forward, that's really, really important. The other part is, for our experience at Innovate UK, is really getting across what the value add is. You know, is this going to make £2.50 at the end of the year difference to your product, or is it going to make, you know, £100,000 different, or £1 million, or £10 million different? Because they need to know there's an exploitation path. To do that, you've got to show them what that step change is. I agree. Get a consortium around you can help you do that, help you explain how to do that. So the catapult's really, really good at helping you get that innovation message across. So yeah. I don't think there are any limits I've seen from Innovate yet.
Thank you. I think we've got time for one more question. Yeah. 2 seconds.
Can I just ask what is the participation of the academia on the Eureka program? You mentioned a few times that they can participate up to 30%, but is academia able to apply directly, or does it need to be one of the partners on a Eureka?
Yes, so in order for an academic to be a participant in any of the Eureka projects where they are looking for funding, Eurostar's academics may participate, but there's no funding for them. In the cluster model, academics may participate and will receive funding, but it's based on, in terms of the participation, there needs to be a business, an SME stroke industry partner from the UK in that consortium for an academic to participate. So we won't allow an academic to participate on their own from the UK. There must be a business partner in that consortium. Sorry, I didn't quite hear that. Yeah, of course, yeah. So a Eureka grant will cover all the typical Innovate UK funding costs. So labour, material, overheads, travel and subsistence, etc. As you know, for those that have had Innovate UK grants before, we don't pay for capital expenditure, we only pay for capital usage depreciated over your lifetime of your business policy. That's it. I'd like to thank Rachel and Stephen for coming along, and I'll be around for a bit, so if you do have any questions on Eureka or EIT, please let me know, and we're happy to help. Thank you.
Right, wonderful. Thank you ever so much, and a very good morning to all you lovely folks joining us here in person, and I see the camera there, so joining us online as well. My name is Anshuman, and I'm the UK's Horizon Europe National Contact Point for Cluster 4 Industry. We'll find out what that means in a bit if you're new to Horizon. And also the Global Innovation Lead for Manufacturing and Materials. So I've got a feat at based at the manufacturing and materials team, but also at the global team, depending on where the discussion agenda is. Over the next few minutes, I have the privilege of taking you through what Horizon Europe, arguably the world's biggest research and innovation framework program, is all about, and what it has to offer, particularly for those working in the materials, manufacturing, minerals, construction, and textile sectors. Following which, you'll hear from Rob Arnold, who's made an entry right on time, from Hypermag Limited on one of their Horizon Europe projects. But before that, here's a little bit about UKRI, if you were not part of the previous presentations but would still like to know what we do. One can say that UKRI is the grand conductor of the UK's Research and Innovation Symphony, orchestrating 9 key sections to drive progress across various themes, including science and technology. And Innovate UK is perhaps the dynamic percussion section, providing the rhythm and energy to drive innovation in particular forward, turning ideas into impactful market-ready solutions with powerful impact. But that's not the topic of the day, though, is it? So we go to the actual gravity center for today. The next set of slides will tell you what Horizon Europe is, who can participate in it, what the typical funding rates are, and who NCPs are, alongside myself. But first, could I please have a show of hands in the room from who have already participated in Horizon Europe? Okay, brilliant. And from those of you now who know what it is but have not quite taken the plunge yet? Right, and from pretty much everybody else in the room, please, who know absolutely nothing about Horizon and would like to start from today. Oh, it's a very even split. So that helps me orientate my content pretty well. So let's get started. By the way, before we begin, for those who know what's already coming, the first set of people who raised your hands, massive apologies for content being quite repetitive from discussions that either we or other NCPs might have had with you in the past. Right then, let's begin. Horizon Europe is also called Framework Programme 9, so obviously it's the 9th framework programme of the European Commission, and is worth a massive 95.5 billion euros over the course of its lifetime. Now, do bear in mind that this does not include contributions from non-EU countries, so if you do add that into account, the figure is a lot bigger. The entire program is split into 3 pillars. So one is focused on excellent science, number 2 is focused on global challenges and European industrial competitiveness, and finally, Innovative Europe. Now, for ease of understanding, I'd like to picture that these pillars are spread over an imaginary TRL spectrum. Right, let's start with Pillar 1, mostly covering early TRLs 1 to 3. The European Research Council, or the ERC, calls are meant for principal investigators in universities and research organizations. The Marie Sklodowska-Curie actions, or the MSCA, calls are meant for PhDs and postdocs. And the research infrastructure calls are meant for collaborative work among research infrastructures, obviously, in different eligible countries, though not meant to build new ones. Now, these are not exclusionary per se, as some of the calls in Pillar 1 encourage collaboration with other companies as well. As we move through the imaginary spectrum, in Pillar 2, you will find a wide array of sectors grouped into thematic areas called clusters. All of what is on offer in this pillar is top-down, meaning the objectives, scope, and the expected outcomes are clearly laid out by the Commission for the stakeholders. Now, these cater, obviously, because we've progressed through the spectrum, to the mid-TRL range, so let's say beginning 3 to 7, which could be further split into two parts based on whether the specific call topic is research-heavy or innovation-heavy. I'll explain more about that in a moment, but that pink box in the middle of Pillar 2 that you see is Cluster 4, and this is where my remit of industry sits. Now this covers, as you spotted in the introductory slide, manufacturing, materials, minerals, construction, and textiles. Now this might answer why there cannot possibly be a single national contact point for the entire program, or even for a pillar, or even a cluster for that matter. But I'll tell you more about that also in a bit. But before we move away from the clusters, let me also tell you that the participation in clusters is consortium-based. And finally, that little bit at the bottom of Pillar 2, which talks about the Joint Research Centre, is all about basing the research and innovation deliverables on the 33 different portfolios that the European Commission has. And these are science and knowledge activities which support the 7 Commission priorities for the next 5 years. Now, these then inform a wide range of EU policies by providing evidence and technical know-how independent of all private or national interests. I don't know how many of you have seen this before, but the collaborative doctoral partnerships, or the CDPs, are one of their most popular calls. Just for the avoidance of any doubts, academic and non-academic, public and private, for-profit and non-profit organizations of any size can participate in Pillar 2. And lastly, we've got Pillar 3. Obviously, it covers the rest of the imaginary spectrum, so we have moved further. It's also interestingly considered to be a microcosm of Horizon Europe in itself. Now, this is because the European Innovation Council, or the EIC, is split into 3. So it's got the Pathfinder program, the Transition program, and the Accelerator program. Each of these are meant to cover the 3 different slices of my imaginary TRL spectrum. So if you had a vertical picture before, you could also have a horizontal picture before, you could have a vertical picture now when you look at Pillar 3. To be specific, the EIC Pathfinder is for multidisciplinary research teams to undertake visionary research with the potential to lead to technological breakthroughs. EIC Transition is to turn said breakthroughs into innovation opportunities following up on results generated either by the EIC Pathfinder, but also interestingly, from the ERC proof of concept projects from Pillar 1, and those from clusters in Pillar 2 as well. So there's a very good linkage that EIC has with the rest of the framework program. And there's the EIC Accelerator, which is for startups and SMEs to develop and scale up those innovations with the potential to create new markets or disrupt existing ones. Now, do note, however, that UK companies can only get grants from EIC Accelerator, but not equity funding and investments, as this is the only part of the entire program not included in our association agreement with the Commission. There's also 2 other parts. You've got the EIEs, or the European Innovation Ecosystems. These are initiatives designed to strengthen and connect regional innovation ecosystems across eligible countries. Their aim is to support the creation of innovation-driven growth by fostering collaboration between businesses, universities, and research centers at the regional level. So you've got to really zoom in and make sure that the participation is at the regional level activity, helping to scale innovative solutions and address specific local challenges. And lastly, but definitely not the least, you've got the European Institute of Innovation and Technology, or the EIT. The expert is also in the room today. You've got Ben Morris, who led the previous presentation, so any questions to do with EIT should be directed his way. But for you to get a good idea of what it is, EIT fosters innovation by supporting the integration of business, research, and education through 9 different knowledge and innovation communities, or KICs. You will get a kick when you start participating in EIT, so that's probably why it's called that way. Now, the goal singularly for the European Commission is to make sure that sustainable growth and job creation is accelerated across Europe by addressing global challenges with innovative solutions. Among the 9 different kicks that that I spoke of previously, you've got 2 which are particularly important for those in the room today. So you've got one on advanced manufacturing and on raw materials, both of which always are good with their booster calls and skilling opportunities as well. Now, I've covered the pillars. If you were observant enough, you would have already spotted the foundation beam, which is supporting the 3 pillars. So it's not just about the pillars. The beam covers something called WIDERA, which is an acronym of its actual name, which you can see on the screen. It's longer than mine, believe it or not. And it aims to reduce research and innovation gaps across European regions. It supports less researched and lower performing countries by fostering collaboration, capacity building, and increased participation in projects across the board. Now, I hope this gives you a good idea of what Horizon Europe is overall. Of course, we are open for questions later, but swiftly progressing to the next slide, you'll be curious to know which countries then are part of Horizon Europe. Easy answers. EU 27. Is it 27 still? EU countries. You've also got associated countries like the UK. Fun fact, this framework program has taken interest pretty much in different parts of the world. You've got countries like Switzerland, New Zealand, South Korea as of this year, and Canada, particularly with Pillar 2, were also participants within Horizon Europe. So you could pretty much select partners from outside of the EU as well. Please do keep in mind to keep your consortium, if it is a consortium-based activity, EU-centric. And the links here give you the specific details, so please feel free to access them once you receive a copy of the presentation. So just for the want of time, quickly zoom in on Pillar 2 now. We will continue to zoom in as we go along, but prior to that, this slide covers the 3 main types of action that I told you, and the funding rates based on each of the said actions. Now, each call topic within Pillar 2 also has a predefined type of action alongside the other things that I covered. If you remember, Pillar 2 focuses on the mid-TRL range, so that's TRLs 3 to 7. So this is what I meant that it could be further split into 2. So you've got the research and innovation actions, which takes care of the research-heavy part, and the innovation actions, which covers the other half. And yet again, for the more observant ones, I can already see faces with squinty eyes asking me, well, what's the third type then? It's called CSAs, or the coordination and support actions. These are meant to cover peripheral activities and not research and innovation themselves, such as forming working groups, networking, having a regulation review, communications, organizing conferences, etc. Now, the idea is to make sure that once you have the ecosystem ready for research and innovation, CSAs would further lead to follow-on actions. There are also other types, obviously, like pre-commercial procurement and co-funded actions, but they're not as frequent as the 3 types that you see on the screen, but we'd be happy to take questions about those as well. And before we get to the gold mine for today, we'll also tell you what NCPs do. The QR code here takes you straight to the gov.uk webpage with a list of all UK NCPs, including Ben and myself, each responsible for different parts of the Horizon Europe diagram that you saw previously. The URL is also helpful for those who would like to hear from us about the latest Horizon Europe news and opportunities. So the newsletters, we promise to not spam you. You could also select which exact part of the framework program you want updates on, and those are the only NCPs which will contact you at the end of the day. Now, quickly switching gears, we move to the next set of slides, which tell you what Pillar 2 is, how it looks like roughly, who the key players for Cluster 4 industry are, the key focus areas or orientations for 2025, the draft work program, or whatever little I can tell you about that right now, because the NCPs are still under embargo. The upcoming info days, I could tell you a lot more about that because it's made public by the Commission, and a summary of what is on offer for the manufacturing and materials community for 2025. And there's also some data for the history buffs in the audience, so if you do want to explore what the statistics from 2021 are, then that's the slide you need to take confidence in before you actually press the apply button. Right, so pillar 2, it's quite interestingly structured because it's exactly like what the slide tells you. So within a cluster, you have destinations which define the calls. Every time a new work program is launched within Horizon Europe, it will contain calls with the aim of fulfilling the Commission's expected outcomes by the end of the project. If one were to imagine the Commission taking a taxi ride on the road of research and innovation policy, then these destinations are where the Commission would ideally like to reach by the end of the framework program. So for example, one of the destinations within Cluster 4 Industry is Twin Transition, which focuses on achieving global leadership in climate neutral, circular and digitized industries. So if that was their goal, they would ideally like for all the projects that participate within this particular destination to reach that particular endpoint by 2027, which is the end of the framework program. Now, these destinations would then have either single or two-stage calls, which further contain various topics with unique identifiers. So they're alphanumeric, but you could very well make out what it means because they've gotten the destinations encoded within the call text. All participation, now this is for those new to Horizon Europe, is at this topic level. So everything that you saw before the topic levels were what informed the particular engagement point that you have with Horizon Europe. Now, to better understand the background to the creation and management, and I promise not to take more than 15 seconds, you will find different departmental and other entities responsible for creating the Horizon Europe Framework Program. You've gotten DG RTD, which is akin to DCIT within the UK. You've also gotten DG GROW, which is similar to the Department for Business and Trade, or the DBT. These are the central policy players alongside HADEA, which is like Innovate UK, meant to manage projects and create those innovation clusters. Not the same clusters that you saw before, but clusters within the management of the research and innovation program. And then you've got public-private partnerships, which take care of the formulation of calls and topics before they get drafted into the work program. Something is quite important to understand, and that's the raw materials partnership within the entire list that you see on your screen. We have yet to confirm commitment to the new raw materials partnership, but our stakeholders are members in every other partnership. You could potentially become a member too, so if you're interested, please do contact the NCPs and we'll tell you more about what being a partnership member is all about. And then there's this tiny little box on your bottom right, which is the NCP for Industry Network. Now this is a CSA. Remember the third action on one of my slides? So this is a CSA of NCPs from different eligible countries. We share best practice and attend program committee meetings organized by the European Commission to make sure that the applicants are fully aware of the calls and topics before submitting their applications. Right, so this has been a quick whistle-stop tour of what Horizon is, what each part of it contains, and who NCPs are, etc. What will follow next, I promise, is gold dust. The next 4 slides are important for those waiting to apply once the calls are advertised, and they contain orientations published around the same time last year to get stakeholder inputs to inform the upcoming set of calls. Bear in mind that an orientations document is a precursor to the draft work program, as it lays out what the tentative ideas and priorities of the Commission are for each destination. Inputs on orientations, give me 1 second, sorry. There you go. Inputs on orientations are then picked up during the program committee meetings, which NCPs and nominated delegates attend to refine and finalize before they get translated to calls. I was about to ask you to get your phone cameras at the ready, but I see many of you being very proactive, so thank you very much for that. Destination 1 is Twin Transition. I've covered that before, but I'll still tell you what it means. So this is meant to achieve global leadership in climate neutral, circular, and digitized industrial and digital value chains. Topics under this destination will cover manufacturing, energy efficient industries, or foundation industries, if you will, and construction. Destination 2 is for achieving technological leadership for Europe's open strategic autonomy in raw materials, chemicals, and innovative materials. Give you a second to take a photo of that. Usually this is where Cluster 4 Industry ends, right? You've only gotten 2 destinations ever until this year, where the Commission has decided you can't silo in an approach for research and innovation for this particular area. So there are some parts of the digital remit within Cluster 4 which have now been pulled into industry. So the next two slides will tell you exactly that. Now this one is for those interested in achieving open strategic autonomy in digital and enabling technologies. Topics are expected to cover the role of AI in science. And finally, there is Destination 6, which addresses digital and industrial technologies driving human-centric innovation. Quick caveat before we go to the next slide. The Commission is yet to officially publish the final work program for this year, but a popular third-party forum has unofficially published the latest known draft work program, which can be accessed using the URL on this slide or by scanning the QR code. No promises from me as to whether this is the final draft that has been taken forward for approval, but this has been shared with the stakeholders, and many stakeholders from different member states and associate countries and third countries have already started looking into it as their guidance document before the final publication happens. I'd be very happy to meet you after this presentation, or for the benefit of online attendees, join an online meeting to discuss more about any call that you find relevant or interesting from this particular draft work program. I'll give you the caveat again. Please note that draft calls are subject to change prior to final approval. We'll know more about this in this event, because these are the info days which the Commission organizes, where you could directly hear from the experts about the final work program. Now these will be on the 13th and the 14th, but for those interested in Cluster 4 industry, a vast majority of the discussions will only happen on the 13th. Now, from what you've seen, you deserve a summary, so the next slide gives you exactly that. The calls are expected to open end of May and close late in September, giving you a period of about 4 months to find the right topic, have your concept checked, build or join a consortium, have your proposal checked if need be, and submit your application. We always recommend interested parties to get started as early as possible, because sometimes, forget 4, even 6 months are not enough. And it's not ideal if it's over summer either, so please do get in touch as soon as possible with the NCPs to discuss potential concepts before you proceed with the next steps. But just to cover everything else in a nutshell, you've got 30 different topics and over 500 million euros to explore purely within Cluster 4 industry, so you can imagine how much more that you can explore from the other parts of the work program. Right, history buffs. The slide for you is here if you're looking for reassurance as to whether you need to apply or not. Too bad that Horizon began only 4 years ago. The predecessor was called Horizon 2020, and the UK namesake which preceded even that is something which nobody here wishes to talk about. But here are some interesting points for the UK in Cluster 4 industry since 2021. Now, again, I promise this is the last time I ask you for show of hands. Whilst you read this, could I get a quick show of hands to check for SMEs in the room, please? How many of you are SMEs? Lovely. That's a vast majority. Thank you, by the way. And alongside the key statistics that you see here, you'll be pleased to note that in 2024, our SMEs, for the very first time, have breached the 70% mark for all company participation in Cluster 4 industry. Now that tells you something, right? It tells you that there's alignment, yes, but there's also appetite. There's also great support, which I'll show you in the next few slides, because it's growing every year, irrespective of the type or size of the organizations in the UK. We like de-risking participation as much as possible too, so whilst I have your attention, SMEs, I have dedicated my last slide for you. This will detail the 2 types of support that you have been getting and may continue getting once the public sector spending review is complete, hence the TBC. But it tells you that you have support available to attend different events in the UK to make sure that you build your consortia. It covers travel and accommodation and is to the tune of £700. You've also got something called the Pump Priming Scheme. This is worth £5,000 excluding VAT, which covers proposal development, conference travel costs, membership in partnerships, and more. Now, the QR codes are for each of their web pages, which will get updated as opportunities emerge. Please do bookmark them and send us your applications when made available. Just one last point before I conclude. If you are a university or an RTO, any university or RTO in the room? Probably not. Oh, two. Excellent. But also for the benefit of those online, there is another pump priming opportunity by the British Academy. Now that is worth £10,000. I'm only the messenger right now, so any questions to do with the British Academy pump priming scheme should be directed their way. And with that, I thank you for your time and attention over the last few minutes. Please join me in welcoming Rob Arnold from Hypermag to briefly talk about their participation in the Resilience Project. Welcome, Rob. All yours.
Good morning, all. I hope nobody has followed me from the circular economy talk this morning. If so, you did. Thank you very much. I can sign an autograph after. Apologies to yourself and Enzo. There will be a few slides repeated. Good morning, all. My name is Rob Arnold. I am the technical manager for Hypermag. And actually, what we do is we're in the business of recycling of rare earth magnets. So we look at capturing rare earth magnets from a component level, breaking them down, processing them, and then producing new magnets for the supply chain. We do this in the UK. We're closely affiliated with the University of Birmingham, where the technology was developed and patented, and we are the exclusive licensee. As of this moment, we're also developing a facility in Germany and in the US at the feasibility stage as well. Now, what I will be talking about today is a little bit of our company background, and I'll come on to those slides shortly, a little bit of what we do and what space we're operating in, before moving on to talk a little bit about our engagement with Horizon Europe, discussing, as Anshuman mentioned, the Resilience Project, but then also a new project that's just launched called iBot for CRMs. Apologies, I will stand slightly to the side so I can see the slides. Fantastic. So, as I've said, we are a recycled magnet manufacturer. The key thing when we look at our process is actually when the demand for rare earth elements. Now, if you look at the criticality registers, and that doesn't matter whether it's the UK, whether it's the EU or the US, the light and the heavy rare earths score near the top on almost every metric. The reason for that, apologies, the slides were doing this in the last session as well, so I will have to return to the proverb of 2 steps forward and 1 step back. These heavy rare earths are super critical for electrification, and actually when you look at the estimated volume in things like EV cars, somewhere in the region of 1 kilo to 2 kilos is used just in the drive motor alone. When you look at the projected volumes of EVs, not only in Europe but also coming in the UK, the demand for these materials will vastly outstrip the potential supply. We believe that recycling provides an opportunity to mitigate against that supply risk by capturing the NdFeB material that already comes into the UK within components. And there's an estimate of around 25,000 tonnes per year is coming in things like loudspeakers, electric drives, actuators, and so on and so forth. When you look at the economics for setting up a primary facility, we have various issues in the UK. We don't have much indigenous rare earth supply, and actually the infrastructure from an environmental and an ethical point of view can have some considerations. From an economic point of view, we think we have a process that's cost effective and is quick and gets us to a material that has various points back into the supply chain, such that we can return that critical material rather than being in the landfill to a point in the supply chain. The flow diagram that you can see on the right hand side gives you an example of what it takes to go from the mine stage to the magnet. It's grossly oversimplified. If you'd like any further details, please come and see me. We are on booth 2. When you look at the layers of that flow chart, the 4 arrows on the top are massively energy intensive. They require huge amounts of infrastructure. That's where your environmental concerns come in. And most of the typical or conventional recycling for NdFeB at the moment is done in the 2 red arrows up there in the top right. Now, when you look at that, I would like to make a hard point that actually this is significantly better than digging it out of the ground. And I do want to make that very clear. The mining uses a huge amount of infrastructure, land, and actually there is a statistic I've heard as recently as this week that 5% of the world's energy roughly is on crushing rocks, and that's what comes into that beneficiation stage. So we want to do everything we can to shorten this supply chain back to a magnet. That's where we think our niche is, because we're able to come right back in at the bottom step, which is magnet manufacture. So the material that we extract from components is an Nd2Fe14B alloy powder, and we can purify that mechanically, so we don't do any chemical processing, and turn that straight back into a new magnet. Why this is advantageous is actually the biggest challenge with recycling is on design for recycle. Do we have any component designers in the room? Any product designers in the room? Fantastic. Roughly 10 years ago, I would estimate that design for recycling was not really discussed. I've been in this job for 5 years, and actually the growth in people discussing designing for recycle has been exponential since then. Now, because of that, if you look at things such as an EV motor, so the top left image, the black stripes that you can see there is something called a transfer molding. Now, that is actually an injection epoxy that is designed to go around the magnets that are embedded within the lamination steel and lock them into place. Motor designers will tell you this is a necessity because it reduces vibration and increases efficiency. However, that means that extraction of the magnets at end of life is particularly challenging, assuming you have a cost-effective method of getting the rotor out. We know that we can take components such as that one, and if you can remove the rotor from the motor, we can process it and we can recover the rare earth material from that. The residual ferrous material we also capture, so that can enter the supply chain in the normal point there, okay? When you look at other things such as hard disk drives, that's been a huge market for us. The reason for that is it's what we consider a low-hanging fruit. So hard disk drives are already processed and shredded in bulk at data centers. Quite often you have to have secure destruction, especially if you're looking at GDPR considerations, especially when you start entering the world of defense. We have a line that has been built as part of a previous Horizon Europe project called SUSMAG Pro by some colleagues in Spain and Sweden that developed a crop-in line that actually takes the corner. So it's the bottom right corner as you look at that hard drive, which is called the voice coil motor. All of the magnet material that we would be interested in is in that corner. This crop-in line cuts that off, reduces the volume economy, so we get more product out, but also it means the rest of the platter can go the conventional shredding route straight away. Hard disk drives are shredded because they have a lot of precious materials in them. As we take that forward, I've just briefly mentioned SUSMAG Pro. SUSMAG Pro ended in 2023, and there is actual spiritual successor to that in this project called Resilience. Now, Resilience is designed to take a holistic approach to the supply chain. What that means took me a while to figure out, but what we're actually looking at is we're looking at securing the supply chain from various directions. So I've already mentioned recycling, and we believe that we can play a key part in the mitigation of that supply chain risk. And you'll notice that our colleagues at Hypermag Germany also feature in this project. But on top of that, we're also looking at methods of how you can minimize the pre-processing. So how can we actually shrink that cropping line down? How can we make it faster, more economical? How can we apply that technology of sensing and sorting into other scrap sectors? We have tier ones, and we have other magnet manufacturers in there. We have long loop chemical recyclers in this project, because actually we believe that our separation capability makes us a perfect addition to the supply chain for long loop chemical suppliers. One of the biggest challenges surrounding chemical recyclers is the removal of the magnet from the component. Actually, our technology has that niche where we can do that in a cost-effective and fast manner. We also have research institutions in there, so University of Birmingham, again, who we know very well, but also institutions like the Joseph Stephan Institution in Ljubljana, as well as the Technical University over in Bath. The key thing for these is to look at that lower TRL that Anshuman mentioned earlier, and in actually making sure that we're engaging at various levels across the TRL scope. More recently, we've started a project called iBot for CRMs. Now, I will come into a little bit why I've decided to talk about this project, but this is predominantly a robotics project. So we're actually in here purely as an end user. Now, the company that have set this up, so the Norwegian Centre of Research, or NORSE, they were looking at not only do they want to develop new technology for sensing and sorting and robotic waste handling, but they also want to demonstrate how it fits in real world application. So how can we show that actually the necessity for these changes to waste handling has a real world drive? How do you justify not only the funding, but how do you justify potential future investment for those? Again, as I said, it's predominantly based around sensing and sorting. Where we fit into this project as a fairly small partner is we're actually working closely with Volt and Tofas. So Volt are a motor design company in Turkey, and Tofas are one of the biggest automotive builders in sort of the Asia area. As part of this project, we will recycle Volt motors. We will create a new magnet. Volt will design to that specification. They will install a motor into a Tofas vehicle, and as far as we know, it will be the first vehicle that will actually go on the road with a fully recycled magnet motor. We're doing a lot of recycled magnet testing in motors, but as far as we're aware, it will be the world first to actually have one sat in a car. Now, I've tried to end this with a few tips and a few points of view on why I think these Horizon projects are great, and hopefully it aligns well with what Anshuman has said earlier. So it's a fantastic platform for collaborative R&D. Number one, your consortium size tends to be larger. And I think when you look at the sort of scope that you have in these projects, conversations are the most important thing for R&D. I think competition can sometimes breed out collaboration. So actually having large consortiums which potential overlap can promote real discussion. We're actually finding that the more we go into the resilience project, we're looking at doing more and more on the pyrometallurgy side, which was initially a very low TRL scope for one of the technical universities in Germany, but we've now realised that our off-spec material can feed that process. If we can then generate a pyrometallurgical process for that, again, we're diversifying that supply chain, we're mitigating against the supply risk. You have to apologise. So, naturally suited to consortiums of varying TRL. One of the big benefits for us as a SME on the cusp of commercialisation is actually that we still have some flexibility in our path, and we still have some flexibility in our ideas and our method of thinking. By still engaging with those low TRL research considerations, at our size, we can accelerate quickly in chosen directions that we think would be useful. So again, I would encourage that where possible. Significant aid for companies looking to scale. I don't need to summarise that. Anshuman has already done a significant good job there. The one thing I would mention is the travel award and the pump priming. I think those are fantastic measures, especially when you're looking to build a consortium. I know we all got very good at Teams during the pandemic. However, there's nothing quite like meeting face to face. So those travel awards can have a huge impact. And then finally, scope. So engagement with larger audiences and larger networks. The UK as an island, I think we do generally fairly well at engaging with our neighbours in Europe. However, having partners that are more willing and more able to engage in the European mainland can have massive benefits. And when you engage with these larger consortiums, you will find yourself, from a business development point of view, tapping into markets that you otherwise wouldn't have been aware of. So a final few tips from me. I'm hoping that has worked. Okay, yeah. Be approachable and open to engagement. So you heard me say the iBot for CRMs project, we were actually invited to join that. So we were not involved in the conception whatsoever. We came in at a fairly late stage. The organisers approached us and said, look, we have an interest in an end user. We've come across you. We think you'd be a fantastic candidate. We joined that consortium and actually we're already finding within the first 6 months of the project that there's fantastic business development opportunity out there. Build a strong consortium. And this is where I think everybody in the room will have their own sector that they'll be engaged in. And the key thing about building that strong consortium, I would say, is be considerate in your ideas and be willing to take a risk at the idea stage. Because actually when you are building the proposal, you may go through 3 or 4 different tier ones, depending on your consideration at the time on who you're engaging with. You may start with a different target OEM than you may end up with. So I would encourage you to take a risk when you're building your consortium and engage in as many directions as you can. And then ultimately that will mean when you get to the proposal stage, you will end up with the best consortium and therefore the best project moving forward. I've mentioned the pump priming and the travel award. The thing very, very important to mention is the NCP. The NCPs are fantastically knowledgeable. They're well connected into Horizon Europe, and therefore that means they are your #1 port of call. I know I need to tap up Anshumam at some point today to come and see us and have a chat about future contests. So I suggest you all do the same. And then finally, think outside the box. Not every proposal has to be huge TRL designed to conquer the manufacturing world. Not every proposal has to just be scaling up something that's already different. My suggestion would be think outside of the box, engage with the NCP on whether you think the validity is there, and try and build that consortium. And I think with that, I'd like to thank you all for listening. I know that's a bit of a whistle-stop tour, so we are on booth 2 if anybody wants to come by, and I'm more than happy to discuss about our experience with Horizon as well as what we do. So thank you all.
I think we've got about 5 minutes for Q&A, so if people in the room have got questions. Yep, Kevin, go for it.
What are the success rates like for applicants?
Yeah, the touchy topic. Success rates at the moment are at about 15 to 16% when it comes to Horizon Europe on average. And for Cluster 4 industry, to be particular, I think my slides summed it up. We are exactly where we want to be, near the average, just above the average, I think. And the reason is the project proposals are getting better and better over time. Consortiums are also getting better, and that is the natural direction of progress that you see when it comes to any framework program, including calls within the UK for that matter. So there are criteria which people have to meet, which are either mandatory or optional. People have begun ticking the optional boxes as well, and that's why the rate is where it is right now. I'm not too sure if we could influence the success rate, but I think what is happening is the UK is now associated, and we could be getting better with time in terms of the numbers. So 15 to 16% on average, but for Cluster 4 industry, just above 16% is the answer. All right, thank you. Just a second, I'm going to get the mic, sorry. It's for the benefit of the online audience.
So, yeah, more some comments rather than questions. So Gerhard Goldbeck from Goldbeck Consulting, and also from the European, I'm also the Executive Secretary of the European Materials Modelling Council. I've been in very many European projects with my company, I think 8 or 9. So if anyone has any questions, I'm happy to support you. There's been quite a change in terms of the assessments since it's done by Hadea, which I think is also an opportunity for people that haven't been in there. I think what I've seen is it's been quite disruptive in terms of the traditional players maybe not getting quite as much of the cake as before. So opportunities exist there. It's more impact related. So again, opportunities exist there for the UK, definitely. And the other thing is, in EMMC, we're organizing, already had one very well, with 90 people registered and 55 stakeholder sessions for building consortia, because as you know, the deadline for submission will be September. The final programs come out in May, which means that all of the consortia building is already happening now. So if you're interested in any of the calls, of course, that's a community that I represent that is in the digital modeling and characterization fields. So there's a lot of competencies there that may complement what you're doing, but we're covering basically all of the materials calls that have any element of characterization modeling in digital. So sorry,
Lovely, that's a very good shout, actually.
I mean, if you, yeah.
Thank you. So anything to do with digital materials, so basically Destination 2, but also has effects on the extras that you saw when it comes to Cluster 4 Digital going into industry, you know whom to contact. Thank you. Any other questions, comments, bouquets, brickbats? Right, with that, thank you so much. Rob and I are available for follow-on discussions a little later. You could recognize us, me by the forehead, Rob by his very good presentation. So lovely. Thank you so much.
We'll make a start. Thank you. Welcome you to this afternoon session to talk about the Transforming Foundation Industries Challenge, give you an overview of what's happened, what's been successful. It's been my pleasure over the last 5 years to be the Challenge Director. An immense amount of great things has happened thanks to the contribution of an awful number of people, both directly within my team, within the wider Innovate ecosphere, and indeed all of you as stakeholders in the foundation industries who've come together to collaborate so effectively over those last 5 years. It is a bit of a surprise to me to suddenly find that it's 5 years is coming to an end. But fortunately for me, I get to stay at Innovate UK as the now Director of Make and Use, and therefore everything that's going on at this event today falls within my responsibility, and an awful lot of responsibility it is, I've got to say, having heard the keynotes earlier, which I hope you've all also enjoyed. So I'm going to talk, hopefully fairly briefly, if I can get this to go forward, about what the challenge was as we began. But most importantly, I think I'll reiterate what's been said more generally about materials and manufacturing earlier today, that these industries, you know, they produce materials that are absolutely part of our everyday lives. And our lives would not be as we know them today if it wasn't for the fact that we had these materials available, and we have them available at a price which is affordable on a not just national but global scale. And in the future we need to keep that being the case, but clearly also make them far more sustainable than they have been in the past, and are starting to become, as we speak, through the challenge and other mechanisms. But let's just consider that a little further. The foundation industries have been part of the UK economy since the Industrial Revolution. But I would argue that the green revolution that was talked about in the keynote sessions is here, and they must adapt as we move forward. The numbers on the screen show you just how integral they are to our society and our economy, and the impact that they have on our everyday lives. But we are at a turning point. As a challenge when we began, we were looking at certain markers and metrics, not specifically CO2, but certainly it was an important factor as we began. But over 5 years, elements like security of supply and far wider economic metrics have become more and more important as we've gone along. We've used the funding within the challenge to drive cross-sector collaboration and through supply chain collaboration as we increasingly focused on energy efficiency and resource efficiency over the 5 years. And it's imperative, and I'll get back to this later, that we build on what's happened within TFI to deliver cleaner industries for the future and secure our supply chains and the highly skilled jobs we need for the future. So, how did we set about that task? Well, we attempted to roughly, very broadly do 5 things. We wanted to create a wider, more integrated network across the foundation industries. It's a bit hard for us to remember now, but 6 years ago, there was still a lot of silos in terms of innovation between the foundation industries. We hope that we've made a difference and that there's a lot more cross-foundation industry collaboration going on now than there was before. And the data we're gathering, certainly from the people who've been involved in the challenges, in the challenge, is suggesting that is absolutely the case. We also set out to establish any additional innovation infrastructure that was needed. You're always restricted by available resources when you run such programs, and some decisions had to be taken at the beginning. But as I'll show hopefully in a few minutes, we both made a significant capital investment in terms of infrastructure right from the beginning of the challenge. But the success as we went along meant that we were able to access more resources and make more innovation infrastructure investment as we went along. We were trying to create some sector leadership, but I would emphasise cross-sector leadership, whether it be amongst individuals and companies who were already operating in the sector, but also those who were about to enter them and would become the future leaders in these sectors. Industry-led innovation is absolutely key. Without that, we would have nothing, and therefore the advisory group that we had from day one for the challenge was extremely important in terms of guiding the scope for what interventions we were making and how they could best be deployed. But what does that look like in reality? I'm not going to ask him to put his hand up, but if I can get this to go forward. Ben is in the room, who designed, oh, he's put his hand up anyway, who designed this chart to try and describe where we sat and where we have sat over these 5 years. It really is to help pull from university-led research and pull that through towards the more government end programmes, the things like the Industrial Energy Transformation Fund, which is run over the same time period as us, but is more about putting technology that's available but isn't being used as widely as it perhaps should be into operation at industrial plants. So we've made a whole range of interventions, whether it be classic Innovate UK, collaborative R&D. A key thing that we undertook was to work with investors on an investor partnership programme. And also, I would say, enhancing the relationship between academia and industry throughout our time of the challenge. It's not all gone perfectly. Nothing ever does. And whisper it, a few CR&D projects that were funded, we had to make a decision. No, actually, this isn't working for anybody really. It stops. But fortunately, they were few and far between. And I hope the numbers that will follow in later slides will give a good indication of the success we've had. But the key thing is that people across these industries have stood up and taken the opportunity that we were able to make available, even during what's been very trying times. You know, over this 5-6 year period, we've gone through COVID. We've had big energy price swings, increases mostly, that was talked about earlier. You know, Ukraine and the impact of what's going on there on industry and supply chains have all been a factor, and yet a lot has been achieved. So, I'll run through some of these very quickly. I talked about investment that we'd made right from the start, and the big initial investment we made was in supporting the development of a pilot plant at Glass Futures in St Helens. That wasn't just an investment by Innovate UK, it was obviously an investment by the industry, but most importantly it was also an investment by the region, Liverpool City region, and the council, St Helens. It was the combination of us all coming together that has enabled that to be a success, and I'll talk more about it in a couple of minutes. There's been over 300 collaborations created as a result of the interventions on the previous slide, and I'll try to illustrate that at the end of the talk. But cross-industry collaboration, I cannot stress how important we felt that was at the beginning of the challenge, and it's remained so, and we think is one of the big success stories. As we talk to those who have benefited from funding within challenges, the data's starting to flow through as we get towards the end, but it's confirmed that 3,000 jobs have been created as a result of the work that's been undertaken in the challenges and businesses being able to move forward over 5 years. And you know, everybody's always interested in the co-investment that comes. As a challenge, we had £66 million to invest up front. So far, £275 million has been invested by the companies and other bodies who've worked with us over that period. And we know that there is another 100 million in the pipeline, at least. The success of the challenges as we've gone along meant that we were able to make the case for more funding, and therefore we've been able to fund 2 programmes, Economiser 1 and Economiser 2, that have been delivered by the Foundation Industry Sustainability Consortium. So that's a group of 5 RTOs including Last Futures, but also CPI and MPI and the Royce and Lucidian. They've come together and they are now actively working together to deliver the kind of support that companies across the foundation industries need in terms of their innovation. And that's one of the things that we are delighted to see is moving forward into the future, and they are working together to build what they do on a daily basis. Transfire, and Mark Jolly is here in the audience, who led Transfire. A remarkable academic industry consortium pulled together, over 100 organisations involved, and a huge amount of work, delivered many really important programmes, particularly around resource efficiency. Some of the stats, I think, are on there. But I would also highlight the excellent work that was done by Sue Black and her team around equality and diversity in the foundation industries. We had some early work done through ESC that confirmed what we all kind of knew, that women in particular weren't in strong positions right through these organisations, and work needed to be done. And there's actually a podcast series called Equity Edge. If you get the chance, Google that and have a look for it. There are some really interesting discussions around this and the foundation industries. So around about, we also, something that arose as we went along was work on demand-led innovation. We realised, and it's been talked about this morning in other sessions, there's a need to pull through the demand for these sort of products. We've worked on concrete first with some of our colleagues in Innovate and widely through the industry on this structure, and it is starting to have impact, and we hope that very shortly companies in the UK will be beginning to make advanced market commitments in the area of concrete, and we're going to move on and look at packaging, whether it might be the automotive sector, and done some of the groundwork for that. Ian Reaney from Sheffield University pulled together and led the Transforming Foundation Industries Network Plus. Please go and have a look online for the work that they've done. With a really relatively small amount of money, they've achieved a fantastic amount over the last 5 years. There's a network of more than 700 academics and business people, and the ratio is about 60-40 academic to business, which is a lot for something that is just meant to be a research focus piece. There's more than 30 small projects been run. There's some of the companies out on the floor today have been involved in those programs. And it's demonstrated that if you put the right people together, even £50,000 or £100,000 worth of funding can lead in a very short time to innovations being rolled out inside big companies globally. I won't kind of spoil it, but go and have a look through the case studies they've got on their website. There's lots of really interesting things that have been achieved through relatively little early investment. Now, in terms of the overall return on investment from TFI, our investor partnership programme has been absolutely pivotal. As we started the challenge, everybody's telling us our investors aren't interested in foundation industries. You know, it's not a good space for them. It costs a lot of money. You know, it's not like just getting somebody to write some software code to do something. You know, you've got to put big monies on the ground. So we went out and we tested the market, and we found that there were some investors who operated in the space. Yeah, not a huge number, but there were some. And what we managed to do was to bring them together, both to work together and to work with us to start up an investor partner program. And that meant that we were able to fund SMEs as Innovate to give 70% of the cost of their innovation project. But the investor partners were prepared to at least match that. So the effective investment in the companies that were successful was 140% of the money they needed to execute their innovation as part of taking the company forward. And then what happens is, if that's a success, the investors come back. And the multipliers on this now for these companies are extremely high. And if you go and talk to, for instance, Adaptivate and other companies who are out in the foyer, you'll understand about that more. I think it's extremely important, the work, further work we've done with regard to who are going to be the people who are going to take these industries into the future and support them on their journeys. So we've one program, we instituted a future leaders group to advisors alongside a traditional advisory group of slightly more grey-haired people, shall we say. And that's been really influential in a lot of what we've done, and those individuals, including those responsible for FIVE, which is out in the foyer, have come out of that group. And personally, for myself, being able to provide support for women to move forward their careers in these industries and operating a future leaders, a women's leaders program that 80 people have been able to participate in, for me has been a great success, and I know they've taken value from that. And finally, we did some work on working abroad and working with Indian colleagues to introduce to them the concepts of the foundation industries, working across industries, which is very much something new to them, has again led to some good success, and UKRI committing £10 million into a programme for UK-India innovation around the foundation industries. No doubt I'm already running out of time because I can tell I'm speaking a lot more than I intended. I've got time? Got time? Okay, so I will just very briefly spotlight Glass Futures, a large investment as part of the overall funding of the challenge. This will be fully operational in this summer. It's a big investment from ourselves. It's a big investment from the region and the local community and the industry. And they have an enormous number of both UK and international partners that are now working collaboratively, not just across the glass industry. And to be honest, the UK glass industry didn't have this kind of capability and had a bit of a tendency not to work, with each other. They were still a bit siloed between whether it be flat glass or bottles or rock wool or whatever it is. Yeah. So there was a bit of that going on there, but it's bringing an awful lot of investment into the region and into the sector, which will continue to flow in the years to come. Possibly, I've already said enough about the Network Plus, but there's just a bit more information there. I mean, it is interesting for something that is meant to be academic, sort of 100%. The small projects that they ran have secured an extra £3.5 million in investment. Businesses have said, "Oh, do you know what? This stuff I want from this right now," and have continued to follow through from those projects. So, you got that one, Bruce? Will it go back? Yeah, so these are the numbers on the board outside, for those of you that are here, the big numbers. I've talked about the follow-on investment and the amount attracted from the likes of private investors down in the bottom right corner there. But the kind of hot-off-the-press number, work we've done, we've had a third party go out and talk to the projects that have been run on TFI to try to get a good quantification of what it's going to mean in terms of emissions reduction over the coming years. So for the next 10 years, out to 2035, we're now getting good, solid evidence that it's very likely that the innovations and the projects that have been taken forward within TFI will lead to a reduction of 25 million tonnes of emitted CO2 in the UK off the back of these projects. And to be honest, that's something that's only going to grow because it's a snapshot now, and there are lots of innovations still feeding through and yet to go into deployment. So, just to confirm, all that networking and all those collaborations have gone on, and you can see how they cluster around certain areas, but this demonstrates the success that collaboration across the foundation industries has been over the 5 years. So, to finish up quite briefly, I reiterate what I said at the beginning. I truly believe that the foundation industries as sectors are critical for the UK, our economy, and indeed the global economy and society. We know there's a huge amount of change on its way, and we need to meet the challenge and deliver on that. We have, as I look forward, and this now encompasses not just the foundation industries, but everything that is taking place today. In making news, we see we need to be resource efficient, we need to be net zero, resilient, responsive, and technologically advanced and digital. It was talked about in the keynote, but we are updating our materials and manufacturing vision. That is really important. It's ongoing right now. So if you can follow the links in either from the keynote session or others, then please do so and contribute to that. So I will wrap up just by saying, hopefully, thank you to you all for your involvement in the challenge over the last 5 years. Hopefully, that QR code will take you to the Foundation Industry page on Innovate UK Business Connect website. That's where you will find all the material around the challenge and all the links to the wider things that are now happening as a result of the challenge taking place. So thank you very much, and time for any questions.
Thank you for that. What are you doing about the actual raw material supply for the foundation industries? Is there work being done on that? Because that's part of the resource efficiency.
Do you mean as in literally digging things out of the ground?
Yeah,
or
what are we
wider
doing
than that?
about supporting the foundation industries, or what are you doing about regards to whether it's sand or calcium or oil or wood, or, you know, the real critical part of any foundation industry is the raw material, its source and where it comes from. And I wonder what you're doing with that and whether that's something, because clearly it's the starting point for raw materials.
Yeah. So in terms of the challenge itself, our main focus has been from the raw materials coming in and through production processes, but then out of the back end and round the circular piece, and what other sources of materials we can have to use higher levels of, like, what's the word I'm searching, can't get the right word out of my head. The sort of not just taken straight out of the ground, you know, it's around the circular economy back in. So that's been our focus, and trying to make processes more resource efficient inherently, so that you're using less of all of those inputs as well, but producing the same amount of product. So that's really where our focus has been. Well, yes, Mark. Yeah. So Mark and his team have been absolutely looking at the industrial symbiosis piece, and a good number of the projects we funded have been about establishing that the waste coming out of one of these industries can be the input to others for various reasons, and there's been lots of successful projects in that area, and establishing that as a firm footprint for the way to move forward.
Yeah, forgive me, I'll read more details about it on the website, but I was wondering if you could comment a bit about what specifically the challenge has been doing in the chemicals sector, and what might be the follow-on work.
Yeah, so I think for those in the chemicals sector, the poster child, I suppose, is the demonstration project that we funded, which is known as Flutichem. So the chemicals industry has been looking at establishing a new supply chain for the production of surfactants in particular, but starting right back from CO2 that's captured. It was captured at 2 paper mills and a steel mill, and has been taken through the whole production process to turn it into surfactant products. So that's involved the likes of Tata Steel and a couple of paper mills right at the front. It's Unilever driving at the back, the likes of BASF and myriad others. I mean, there's actually 17 partners in that project. Now, they've tried to kind of double up in terms of each part in that new production chains to make sure they always had some redundancy built in. But it shows how complicated the chain is to get from carbon in the form of, captured from a foundation industry to a product that you and I are taking off the supermarket shelf. So that's probably, I would say, the main one I'd highlight.
Got a couple of minutes for another question or two.
Hi, thank you. My question is about the private investment that you mentioned. So obviously the different foundation industries will be a little bit different, but for example, in ceramics, there's tight margins, strong dependence on the price of energy, etc. How do you incentivize private investment in these industries when there are potential for quite tight margins?
Yeah, so it's been about really trying to take them on the journey. I know it's an overused phrase. So where we start in terms of our funding, it's in initial levels of funding are only needed often in terms of a few 100,000, perhaps up to sort of $1 million for the early projects, which we will map. But then because we do the, again, words popped out, but we assess every proposal that comes in from a technical perspective, to say this, our experts and their independent assessors to Innovate UK say this looks like it will technically be successful and is worth backing. So we do that in parallel to the investors taking a wider look and talking to the companies, looking over them, and then we come together and say, okay, we will jointly fund to take it forward. That to try and stimulate at that early stage investment, and then of course if it's a project, and I think all but one of such projects that we ran within our investor partnership scheme was successful, and then there's been further investment as a result of follow on. Okay. Okay. Well, thank you very much, everybody, and I hope you enjoy the rest of the event.
Sorry to cut the music, everyone. I know you're enjoying it. But hi, everyone. I'm David Elson. I'm Head of Materials and Manufacturing at Innovate UK, and welcome to this session titled "We Can't Stop Thinking About the Future." So the purpose is to discuss visions of where we think the future of UK manufacturing and materials might be out to 2050. And it's going to be based on the Innovate UK Materials and Manufacturing Vision, the High Value Manufacturing Catapult Technology Roadmaps, and the new National Materials Innovation Strategy led by the Royce. I'm delighted to be joined by two great speakers today from those two organisations. But just before I introduce them, I'm just going to spend a few minutes setting the scene. And I apologise to anyone who was in the last session over the other side, because these are very similar slides, if not the same slides. So the Materials and Manufacturing Vision that Innovate UK published in March 2023 aimed to take an aspirational but realistic look at manufacturing futures for the UK. It was based on a very extensive analysis of documentation, a very large stakeholder engagement exercise, and that was the intention, that we look at a sort of aspirational future, but it's grounded in evidence, so it's defendable as far as we can. So it's very comprehensive. We've used it to inform our strategy and investments, and we hope and know in some cases that it has been used by others to inform their investments. The other important point of putting this together is It's a vision of the future, so it's not all going to be correct. It's not going to be right. As we look further out towards 2050, there is imagination in there. So we wanted to stimulate debate, and it has stimulated a lot of debate. Just a little bit on the structure of the vision. Essentially, we start with three strategic imperatives. The overall premise of the vision is for UK organisations to be internationally competitive. They need to be net zero and resource efficient. They need to be resilient and responsive, and they need to be technologically advanced and digital. And we see that as no longer being a zero-sum game. So there's been a huge analysis behind this and a huge, well, we basically use a SWOT model behind it with thousands of different points from hundreds of documents to develop exactly what those sort of steps towards these imperatives might be. And we've summarised those. Sorry, there's a bit of a delay on this. It's stuck. Okay. We've summarised that out in the document on 10 2 pages. So we've taken a systems approach, looked at 5 core areas of focus, as we call them, from materials, design, production, supply chain, and longer in use and reuse, and then enabling areas in the centre of evolving value models at the core of it, next generation business models, skills, proactive regulations, networked relations, and clean energy. And for each of those, we developed all of that analysis, thousands of points, into 2 pages, where on the left-hand side, we have a global outlook. What are the global trends in the coming decades? And underneath that, there's a logic model. If we want to achieve our strategic imperatives, what are the key innovation strands that we see need to happen to achieve those imperatives? And on the right-hand side of these 2 pages, there's something called a transformation map. And that builds on the UK strengths, looking at those innovation strands, to try and understand the key milestones that we think industry needs to take in the coming decades towards those visions. So that was just a very brief framing, but more importantly, I want to introduce the first of our speakers. Abby Ramesh is the Technology Strategy Manager at the High Value Manufacturing Catapult. Let's hand over to Abby.
Thank you. Good afternoon all. So yeah, I'm from the High Value Manufacturing Catapult. I'll start with a very quick introduction to who we are. So we are a network of world-leading technology and innovation centre supporting UK manufacturing businesses to transform their ideas into valuable products and services. We work at the intersection of academia, industry, and government. You know, we do quite a lot of work with the academic community, and a lot of our work with the businesses is mostly helping the small businesses to innovate and accelerate their sort of time to market. We are established by Innovate UK in 2011, and we're part of the wider Catapult network. So there's 9 Catapult entities, and we are part of the wider Catapult network, and we're one of the biggest among the network. We employ about 3,500 people across the network, and since 2011, we've worked with thousands of companies, more than 16,000 CR&D and commercial projects, more than 36,000 businesses that we have worked with, of which 20,000 is roughly the SMEs. So we have a national presence. We have about 23 offices across the UK, and we work very closely with local businesses, regional authorities, and devolved administrations, and help deliver economic growth in the regions through highly skilled jobs. And last week, we opened a new office in South Wales. In our network, we have access to expert engineers, specialists, technicians, and world-class equipment, where people can make real difference to whatever technology and whatever sector needs are. And we've worked with plenty of amazing companies that are exhibiting today, and we've helped them in their innovation journey. So High Value Manufacturing Catapult, our vision is to deliver industrial transformation for the UK and it's focused on 4 strategic priorities. So net zero industrial sustainability, clean energy transition, healthy living, and national security. So these are the sort of 4 key strategic priorities, underpinned by 5 landscape transformation priorities. This is about supply chain and access to finance, skills and workforce development, AI and digitalization, SME support, and working with regions to help them grow. So our vision is underpinned by a set of core technical capabilities, and these are sort of broad sort of technical capabilities that exist across a network. So I'm not going to go through every single one of them, but there's about 11 core technology areas where our centers have world-leading expertise and knowledge. Our aim is to maximize economic and social impact by working collaboratively as a network, not just within the Catapult network, but also with the wider research and innovation ecosystem across the UK. So David spoke about the Innovate UK Vision 2050 document. So it's a really powerful document which helped us to develop a framework to develop our technology roadmaps internally. So what we've done, we've looked at the key innovation themes that's highlighted in the Innovate M&M Vision 2050 document, which are these ones. Smart design, supply chains, world-class production, long-range use and reuse and materials, and clean energy. So we sort of looked at the external market needs through these 6 perspectives and tried to identify key industrial needs in these areas, and then built our internal technology roadmaps based on the industrial challenges that we've identified through these landscapes. So the landscapes, they're basically meant to provide the external market view, giving a sense of strategic trends and the market pull direction, and then the technology roadmaps is responding to those industry needs. So that's how we sort of developed our roadmaps. And these technology roadmaps, they underpin our 4 strategic imperatives that I mentioned in the previous slide, which is sustainability, clean energy transition, national security, and healthy living. So the Vision 2050 document has been really helpful in developing this framework internally. So our approach to the HVM Catapult technology strategy, we sort of taken 80-20 approach. Rather than starting with a blank sheet of paper, we looked at the Innovate Vision 2050 document, plus we also looked at various other sector strategies, national strategies and policy document. For example, the Royce National Materials Strategy, ATI, APC, EPSRC, and various other sector bodies. We looked at the existing strategies, trends and drivers, industry needs, and then we came up with a long list of industry challenges and needs. We ran several internal workshops, about 17 internal workshops, bringing together more than 120 technical experts from a network to build a view of what we think the future direction of the network and the UK should look like. An outcome from this exercise, we've got 11 technology capability roadmaps aligned to the 11 areas that I mentioned in the previous slide. And for each area, we've identified a number of priority technology pathways and 5 common enabling themes. And it has really helped us achieve consensus and alignment internally as a network. And we look forward to implementing this as we move forward. So these roadmaps at the moment, as I mentioned earlier, the 80-20 approach, these are baseline roadmaps. We know they're not 100% perfect. It's built predominantly using our internal experts' knowledge, but there's going to be more opportunity for others in the wider RNA ecosystem to get involved, provide feedback, and help refine these roadmaps as we move forward. And I'll talk about that in my last slide. We sort of started testing our roadmaps with some of the key external stakeholders, and it's good to see that we are roughly in the right direction. It needs a little bit of tweaking, but hopefully we'll get there soon. So on this slide, I just want to give you a flavor of the key innovation areas that we think are going to make a difference to UK manufacturing. So we think the future of UK manufacturing, I think we stand at a transformative crossroad. The convergence of digital systems, sustainable solutions, and human-centric approach, it's going to bring plenty of innovation opportunities for UK manufacturers. So as we finalize our roadmaps over the next coming months, we'll be able to share more details, but I'm just going to quickly touch upon one or two key themes here. One of the key themes that's emerging from our road mapping activity is the sort of digital physical convergence, where physical factories and production processes are converging with digital twins and AI-based tools, which is creating lots of opportunity to augment the humans in terms of the decision-making, the way we design the products, the way we make and use products and services. It's fundamentally changing the game for manufacturers. Then intelligence-driven design, internally we sort of call this engineering transformation. This is about the phase before manufacturing, the engineering and design aspect. With the with rise in AI-powered tools and predictive design capabilities, and again, it's fundamentally changing how complex systems are conceived and designed. So there's lots of interesting work happening within our network, and the next one is the smart robotics and adaptive automation. So this is about self-learning robots. This could be a game changer for many of the UK manufacturers, where the robots would be able to code themselves. And then we're talking about adaptive automation, where in the past the focus has been around fully automating factories, etc. But with that comes certain risks. When the demand for products changes, you're locked in with your automation, so it removes the flexibility. So whereas with the adaptive automation, the concept is how your automation system can adapt to change in your demands, etc. So that's an interesting area where there's lots of innovation happening already. Advanced materials is sort of fundamental, and it cuts across a number of technology areas that we're working. New composite materials for extreme environment in defense and aerospace applications, for example. So there's plenty of innovation happening in that space, and there's scope for more in that area. Engineering biology is really important. There's a growing market for bio-derived materials and materials that are not based on sort of petrochemical based solutions. Alternative food proteins. So those are sort of areas where lots of innovation opportunities are there for the UK manufacturers. Sustainability has become really, really important. Companies are now looking to embed sustainable circular economy practices within their production environment. And clean energy adoption is really, really a big area for innovation. I think Stephen from Make UK was talking this morning, and he said, how important or how much of a risk this clean energy adoption is, because he said, I think the energy cost in the UK is 25% higher than EU and 125% higher than US, something like that. So, energy cost is a major challenge for UK manufacturers. So process electrification is an area where there's lots of innovation opportunities to help businesses tackle that problem of high energy cost. So it's an interesting area. The rest of it, supply chain network rebalancing. As we all know, global trade patterns, there's a significant shift happening. Companies are looking to reshore and looking at supplier diversification. Digital technologies are playing a huge role in this space. Digital product passports, technologies that enable traceability of products from the moment when they are mined as a materials till their end of life. So there's significant innovation opportunities in that space, and lots of companies are investing in AI-based tools and technologies to get visibility of their multi-tier supply networks, because they want to understand where their products are coming from. Are they sustainable? Because there's lots of legislations coming in these days for ESG compliance, carbon emission accounting and all that. So companies are investing quite a lot in digital AI technologies to map their supply network and understand the risks before they actually happen. So they're looking for patterns in movements of goods, etc., to mitigate potential disruption. So that's an interesting area where there's plenty of innovation opportunity. So I've sort of covered most of them. So the key message there was, those innovation areas that we saw there, these aren't just innovation opportunities for large companies. there's plenty of innovation opportunity for smaller businesses as well. And many of these technologies and innovations, they're sort of already available, and many of our catapult centers are working in this space, and they've got some world-leading solutions that are already ready for companies to adopt. So yeah, this is gonna, these are some of the fundamental technology areas where we think it's gonna significantly change the future landscape for UK manufacturing. There we go. And it's not just all about technologies. There are also some other common enablers that are fundamental for success. From the work that we did, we identified sort of 5 common enabling areas. The first one is around future workforce, making sure we have digitally enabled future-ready workforce available. So there's 2 angles to the workforce bit. One, having the right skills for the future. The other area is the capacity. Do we, as a nation, have the capacity to serve the needs for different sectors? For example, automotive industry, they're investing quite a lot in electrification. Aerospace industry is also looking at electrification as a potential technology area in the future. So do we have enough people to fulfill the needs of different sectors in areas of competing technologies? So that's a fundamental area. And the Catapult network, we're doing some fantastic jobs. So we have the Workforce Foresighting Hub, which is looking at the sort of future needs in different sectors and working with different educators and different players in the ecosystem to make sure we have the right people with the right skills and the capacity to serve future needs. Again, from conscious of the time, scale-up acceleration is another significant area which is fundamental for the UK's growth. And again, this is an area where we are working closely with the investor community, Innovate UK access to finance community, to try and understand what are the real challenges for UK manufacturers. And it's not just about the technologies, but making sure that we are attracting the investors to invest in UK companies that are in need for growth. So watch out for that space. So this slide, it's mostly about, look, we as a Catapult network, we are playing our part in solving national challenges, such as economic growth, clean energy transition, security and resilience. But we recognize that we can't solve all the problem. We're keen to work with other partners in the wider UK R&I research and innovation ecosystem. And we'll use our sort of convening power and the sector agnostic position to continue amplifying the voice of UK manufacturing to the wider stakeholders and the policymakers. Like I mentioned earlier, the work that we've done so far, it's mostly based on our internal expertise, but going forward, there's going to be plenty of opportunities for you guys to get involved, help shape our roadmaps. So between now and June, there's going to be various stakeholder consultation opportunities. And around July time, we have our annual event, which is the UK Manufacturers Forum, which is primarily targeted at academic researchers, where there'll be opportunity for you to learn more about the roadmaps and provide your inputs. And hopefully, we're looking at publishing our technology strategy and action plan around September this year. So there's going to be plenty of opportunity for you to engage with us. If you're interested, please scan the QR code and leave your contact details, and we'll get in touch with you and keep you informed. Thank you.
Thank you, Abby, and a huge amount of work behind those roadmaps. So it's great stuff to have. So I'd now like to invite Professor Ian Kinloch, who's the Chief Scientific Officer at the Henry Royce Institute, to come and give a presentation.
Okay, so good afternoon, everyone. My name's Ian. I'm from the Henry Royce Institute, and today I'm going to be talking about some of the work we've been doing on the, just go switch. Is that better? Yeah, okay. So I'm going to do some of the work we've been doing on mapping out the future of materials through the National Materials Innovation Strategy. I thought, though, similarly to high-value manufacturing catapult, should introduce what Royce is. So Royce is the national National Institute for Advanced Materials. It was founded in 2016 with a major EPSRC investment. When it was founded, it was with Osborne recognizing that materials underpinned manufacturing, and hence it was important to translate some of the advanced materials research and expertise that existed in the UK into the manufacturing sector and trying to accelerate that. Since then, we've built up to now 11 partners, so we have 9 universities in there and 2 government labs. As you can see, we're a distributed national institute where we've got sites around the country working together under the Royce banner. So we have 4 key mission pillars within Royce. The first one is the foresighting for technology and road mapping, and obviously that's going to be the focus of today's talk. The second bit is catalyzing industrial collaboration and exploitation. So again, that is about accelerating technology translation, both from academia to industry, but also industry coming to us and using the expertise within the Royce and the wider UK community to enhance their manufacturing. Then we have skills, which of course is important, as cut across all the conversations today. And then finally, we have about £105 million worth of equipment under our wing. We act that as a distributed national facility. We importantly provide the technical support as well. So if a company wants to come and use that equipment, we provide the expertise to do the experiments and analyze the data. So as I said, we do quite a lot. In terms of our portfolio interactions, a number of these have been actually mentioned today. So we work very closely with Innovate, for example, on analysis for innovators. We also work with FISC, that if you were in this room was just talked about, and all the work on the foundation industries. So we work with the other RTOs as well as with industry. So in terms of the National Materials Innovation Strategy, we've always had a strong road mapping and foresighting mission within Royce. There's a number of roadmaps if you go on our website, so you're looking at things from hydrogen storage, for example, advanced telecommunications, but we realized there wasn't a kind of a national strategy to plan against. So we set up the National Materials Leadership Council and asked them to do a top-down approach to work out what the priorities should be for materials going ahead. And the report came out 4 weeks ago. The link is there for you to see it. Also on the Royce stand, there is a shorter version of it. So there's a summary over on the Royce stand. So please go and see the team, and they'll be able to give you a copy if there's any left. But the first thing we had to do was actually convince ourselves that materials was important and aligned with our mission. So as you can get, it is important. One of the challenges is how do you work out the impact of materials to industry? Because obviously you have your primary materials manufacturers, but then you have companies such as Rolls-Royce where advanced materials underpin their business, but they're not making materials, they're making jet engines or nuclear power. So we separated that apart. So in terms of material-specific primary material companies, there's about 52,000 employees in the UK, and that's contributing 4.4 billion GVA. However, when you take those materials into the next level, we're up to 635,000 employees, contributing 45 billion GVA with 2,700 companies. Importantly, 70% of those companies are SMEs. So there's a lot of SMEs in this space, and engaging and translating technology with those SMEs is really important going ahead. The next question is, what are the priorities? And materials is a big area, so trying to identify what the key materials are in something as broad as materials is a challenge, and we listened to a lot of people. So we spoke to over 2,000 experts, as you can see, 270 organizations, and had a whole range of workshops. And out of that, we came out with 40 priorities. Those 40 priorities included 19 specific materials innovation opportunities, which fed down into 6 opportunity themes with 5 cross-cutting themes. So the overall themes you notice are sector agnostic, and I think this is really important. You want to be able to work across sectors. So I was at a PFAS workshop 2 weeks ago. The problems in the food and beverage industry are similar to the ones in the aerospace. So I think we need to start talking wider across the sectors if we want to innovate quicker. So as you can see, these are the themes. Under each one of these themes, There we go. It's a set of interventions. Now, I'm not going to go and read each one because I would run out of time very rapidly, but you can see the type of innovations that we've got there. So we've got energy solutions, and that goes from batteries to energy harvesting through to nuclear, future healthcare, biocompatible materials, but also bioelectronics. So this includes emerging opportunities as well for the UK, which could be an opportunity for growth in the sectors that aren't really established worldwide yet. We then have structural innovations. Now, we've already had quite a lot on, again, foundation industries and construction. So this goes all the way from construction through to advanced alloys or advanced composites. We have advanced surface technologies, and a big drive at the moment is trying to extend the service life of our existing assets, particularly if you want to reduce carbon footprint, get the assets you already got to last longer, which is kind of in the space of corrosion and control through things such as paints. Then we have next generation electronics, telecoms and sensors, and you expect it includes quantum, but it also includes power electronics for the EV industry and connectivity and telecoms, and then consumer products, packaging and specialist polymers, sustainable packaging, and also sustainable elastomers. So when we look at those areas, they were the areas that we could see interventions for the next 10 years. The brief here was up to 2050. So this is where our cross-cutting comes in. And cross-cutting is very similar to cross-cutting we've just seen, actually, which is always good. Translation and manufacturing, which, of course, is one of our key drives within Royce. Skills, again, which is something we work on. Policy, regulation, and standards. So, again, it's important to try and accelerate that. We talked about developing, say, new CO2 concrete. Take an insurance company 5 to 10 years of knowing how that performs before they're willing to insure a building built from that new concrete. We need to engage the regulators and the insurers earlier and have ways of them developing faith in the products quicker in order for them to get to market. Because it isn't just the economic bit, it's also the insurance and regulation part. And then the two bit I'm going to focus on for the rest of the talk is Materials 4.0, sustainability and the circular economy. If it's going to switch. Tech guys. Thank you. Aim at the tech guys. So if I was being flippant and someone said, what is materials going to look like in 2050? The answer would be, it's the material I discover tomorrow. Because it takes 20 years to get a material from discovery to marketplace. So in some ways, you know, what we're going to do by 2050 is what we already know about. But that isn't really acceptable given the pressures we have on CO2, on need for growth and everything else. So we need to get better at translating and accelerating this. And this is where we start looking at other industries and seeing what they've done. So you look at pharma, for example, and the uptake of informatics, high throughput experiments, but also high fidelity experiments, you realize there's probably a better way of doing materials discovery. So there we go. Okay. So here, this is the idea here that we've now got new advances in materials modeling. We have new advances, of course, in AI and big data. They're able to machine learn from large databases. And also, experimentally, we've got better at doing high quality experiments where we really understand what's going on. Problems those experiments now take longer to do and more costly. So what we need to do is bring all these together and basically come up with this virtuous circle where we're using digital data to drive small-scale experiments that then validate our computational tools that help us then interrogate the data and go round and round this loop to accelerate. So, you know, you talk a lot about Industry 4.0. This is kind of the materials discovery part to try and accelerate this. So you can see two ways of doing this, or multiple ways. I'm going to give two case examples, one of which is kind of the digital twin. So everyone's fairly familiar with twins in terms of manufacturing. What we have here is a materials twin, where on the right-hand side we have the modeling. So we're going from device scale, which is quantum modeling, all the way down to molecular dynamics. And then on the left-hand side, now you can do atomic resolution and various microscopes all the way up to component testing. Now, traditionally, it's been very hard to go from size scale to size scale, and often people working on one size scale don't talk to the others. And likewise, those that are doing experimental don't talk to the modelers. So again, this is about networking, working together, but also bringing it together using data to cross these size scales. So using things like machine learning to take the molecular dynamics up to the crystal plasticity, for example. The other way of doing this is to do, of course, data mining. So in terms of data mining, we need to get better databases. So we have some databases. Getting a standard database for materials is going to be hard because it's not quite like the same as a chemical database, because we need to consider how materials are processed within that as well. It's not just the material structure, it's what you do with it, how you process it, and the history of that material. But this is the type of example you could do. So you have your large database, and then you could search for specific materials domains within there, say magnetic properties or battery devices or mechanical properties, or ideally, where we're going for multifunctionality, a number of these, working out what we can compromise. So an example you can see of this there you go, is here, which is a dye. So this was a piece of work done for looking at dyes for a dye-sensitive photovoltaic cell. So initially there was 9,500 candidates roughly. So if you were a traditionally experimentalist, you would have picked maybe 100 of these, a couple hundred, done a quick experiment and hoped you hit the right solution. However, you can use data to take this down. So you can then start selecting down by the different criteria by mining your database and even doing a bit of modeling there to try and predict what these dyes would do. And then you end up with 29 dye candidates, from which you can do a final selection down to 5. Doing 5 high-quality experiments is a lot better than doing 9,500. So there you've automatically taken down that experimental time, and there you can see you ended up with 2 predicted light harvesting dyes from that approach. So you can see how this can make advantageous, and this is a simple example of going ahead with new materials and new materials discovery. But again, it works with getting good databases and working that experimental divide with digital. The other bit to look at is circularity. There we are. And the circularity, of course, is about sustainability. And sustainability, we've already mentioned, it's circularity, resource efficiency, environmental impact. The other thing I think we should always add to this is you've got to deliver this with it being economically viable as well. You can't do this and not be economical. So you either need good processes or you need regulatory drivers to drive that to make it possible. So the issue with the circularity and where we are at the moment is I would argue we have 2 classes of chemicals and components at the moment. Let's switch. So at the moment we have 2 main classes. We have legacy stuff for which we probably have a rough idea what's within that component. It's probably got a few banned things as well historically now, like fire retardants, for example, that we need to work out how to deal with that, not get it to landfill and extract value out of it. We then have the current stuff that's going ahead, for which ideally has a digital passport with it, so we know what's in it at least, so we know really how to start recycling it. But if we're looking towards 2050, we want to really start considering these by circularity by design. So we then design something that's designed to be deconstructed, remade, and recycled with minimal residual waste. The problem is, it might look like a nice circle here, but really you're looking at things like cross-sector ultimately. Your waste stream may not be in the same sector you started with, and obviously if you change your sector's process, you knock off somebody else's sector's downstream items. So here's one case study from Manchester, which is looking at plastics and a combination of plastics and big data. So you can see here, this is PET bottles that are being recycled. They've used these different techniques to understand how the features change upon recycle, and then use that to identify how much that material's been used in its history, and identify that going ahead. So in summary, that's our strategy. We have our cross-cutting themes looking towards 2050, and then our horizontal themes looking over the next 10 years. Again, similarly to last talk, a call for help. We've got a strategy. We need to deliver a strategy. Deliver that strategy, we need expert and guidance on our working groups. I would ask people that are interested to get in touch. And hopefully, last slide will come up, which is just our contact details. There you go. Okay. So thank you very much.
Thank you, Ian. If I could ask Abby and Ian to take a seat here, we'll now open up for questions. I think both Abby and Ian could have spoken for an hour each at least about the work that's gone on. So thank you very much for squeezing it into a short time. It's a very good effort. So any questions from the audience at all for any of our speakers? Ben, please introduce yourself.
Sure, I'm Ben Walsh. I'm Deputy Challenge Director for Faraday Battery Challenge. Really interesting and very comprehensive kind of the work that you guys have done to date. And I don't think anyone would disagree with the vast majority of it. I guess given that fundamentally we might need to make choices in this space, what would the choices that you make that we should focus on within those bigger pieces?
I mean, I think some of the cross-cutting is important, so that setup of that digital piece would be kind of the priority at the moment because it is so cross-sector, and it would give the UK a leading edge if we move quickly. But it does involve things like standardization of those databases. This modeling only works if you have the data, and how you collect that data, how you hold it, and how you give access to it, and what you then do with that, I think is really important. So I think that would be, if I had to pick one thing which we put money in initially, it would be that, because it cuts across so many other things.
Yeah, I agree with Ian. The work that we did, that's something that came up again and again. The digital thread and understanding the data governance aspect. How do you make sure the data flow is seamless, and how do we make sure the different systems are interconnected with each other, interoperable? So that came across as a fundamental area. And then materials was another area where it's fundamental for a number of different manufacturing technology areas that we are looking at. And then the through life aspect is another area where I would say we should prioritize because as we all know, businesses are focusing more and more on sustainability. With the through life aspect, manufacturers are thinking beyond how they make their products. They're also thinking about what services that they can develop and sell along with it across the life cycle of the product. So I would probably say digital, materials, and through life. Those are the three things I would say.
Okay, thank you very much. Any other questions at all from the audience? Okay, I'll. Oh, sorry. Yes, you're fine.
Hi, my name is Alex Brown. I'm from the University of St Andrews. So my question is in the area of the kind of skills development and the future workforce. Obviously, it's really essential that people are trained and developed for a plan for 2050 to work out. But I see in my own students at every level, bachelor's, masters, PhDs who are graduating, last year, this year. They have, it's chemistry, physics, they have STEM degrees, and there aren't enough STEM jobs out there for them. What I'm getting at is that they won't just not be working in innovation by 2050, they won't be working in innovation in 2026. So how do we kind of catalyze and bridge that gap so the innovation, they're getting into the innovation ecosystem, now and not dropping out at this very early stage in their careers?
I think there does need to be a bit of work, I think, looking at Innovate skills, where the kind of demand for jobs sits and what's missing from our graduates that come out. Because, if we go and talk to the composite sector, for example, they're desperate. The nuclear sector is particularly desperate for workers as well. So whenever we go to industry, skills always flagged. The concern, I guess, from our university point of view, is when I look at my own students, are we training them with those right skill sets? And also maybe coming from the other side, if we're going to be a bit controversial, is what does industry need to add and adapt to where we go? And there's probably somewhere in the middle where we need to meet in terms of that. But when we go around and talk to an industry and we report, skills always comes up. But there's also a range of skills. I think it's important for sitting in university. We normally focus on the degree level above, but there's a huge amount of apprenticeships and everything else when you look at companies and it's like the battery factory going down in the southwest. several thousand level 6 apprentice jobs as well. So I think it's getting that balance of skill sets as well.
Thanks, Ian. One of the key areas of our vision is how we improve our skills foresighting as best we can, and the Catapult's done a huge amount of work there, sort of really try and understand those future skills needs, so we can try and get the right people at the right time in the right place, which is a huge challenge, but Catapult does a lot of work in that space.
A couple of minutes left.
I just wanted to add to that point. Sorry. On the skills bit in manufacturing, one, we need to do a better job of selling manufacturing as an attractive industry for young students to get into. That's one thing. The other challenge in manufacturing, I think, is we need sort of engineers and data scientists with, software engineers and data scientists with manufacturing domain knowledge, and then the manufacturing engineers, we need to sort of upskill them to have a bit of digital literacy and sort of coding knowledge. So we need to do some work in that space. And the other factor is manufacturing. We have quite a lot of aging workforce. Many people are about to retire. So how do we make sure we capture that knowledge and transfer it to the younger generation? And again, that's an area where I think we need more work to be done.
Nice introduction, aging workforce. I don't think anybody would disagree with what you've presented today, but for me, there's an obvious point here. And what are the mechanisms for how it's going to be delivered? How are you going to engage with industry? How are you going to engage with startups? How are you going to engage with SMEs? Because that mechanism needs to happen, really, to make this happen.
I think, like I said earlier, a lot of this, it's already happening, and we're already engaging with SMEs, academic researchers. Catapults are a great mechanism where we help with that translation. And again, scale up, like I said, we're doing quite a lot of work with investors to promote the companies that are in our network. Because we work so closely with the companies, we understand the technology angle. We also understand their sort of business processes and their sort of investment needs as well. So we're doing quite a lot of work to promote the companies in our network to the investors and sort of help de-risk some of their investments. So that's an area where we're doing more and more in terms of the scale-ups.
I think we also need better coordination with the infrastructure we have. I think there has been some, it's getting better. I mean, I think things like SEAMS, for which the Catapults, Roy's universities have been working together, have got a lot better of that single point of contact where companies come in, and it's hard even being inside the innovation infrastructure to work out what bit does what. If you're a little SME, I think it can be quite really intimidating. So I do think much more of this single point and almost holding the hand of that innovation as it goes through the bits of the network is really important going ahead.
I think it's a great point, and we do a lot, but we could always certainly collectively do a lot more, and it is that coordination and communication that we need to do a lot more of. Unfortunately, we're out of time, but thank you very much for your attention. I'd just like you to join me in thanking our two speakers.
Hello. Okay. Thank you very much, everybody. We're just a couple of people coming through the door. Fantastic. Okay. Good afternoon. Welcome to the second session in this futures space where we're trying to think about what the future might hold for manufacturing and materials in the UK. My name's Nick Cliff. I am currently the Deputy Challenge Director for the Smart Sustainable Plastic Packaging Challenge, and I'll just be sort of hosting and comparing this session. So, point that way. Oh, God, yeah, that's me. There we go. So, the idea of our first session in this block was very much to ask what are sort of key partners, what their view of where the future of manufacturing and materials was taking us. So we heard from the High Value Manufacturing Catapult, we heard from the Henry Royce Institute, and we heard from our own head of manufacturing, David Elson, around our manufacturing vision. The purpose of this session was to actually ask some of the small, innovative SMEs that we've funded where they see the manufacturing materials sector going in the UK by 2050. However, here we go. On the right there, I solved it as I typed in to a ChatGPT style artwork program, what does the future of UK manufacturing look like if it is electrified, net zero, and biotechnology based? So there we go. That's our vision of what the future looks like. It's undifferentiated green being manufactured in very clean conditions. This is why we've asked experts along to share their vision of what's going to happen. So we have 3 speakers today who I will, well, they'll introduce themselves. But we have James from, I've got to guess right, AEM. We have Doug from Matter. And somewhere we have Jen, who's thought I'm coming through. She's be here in a minute, from the BBIA. So thank you very much. Each of the speakers will get 10, 12 minutes to talk to you about their vision of the future. And then with the time we have left at the end of the session, we'll open it up to any questions you have, either directly for the companies or more broadly on manufacturing if you're a small enterprise. Thank you. So, James.
I think I can speak into this. Is that okay? Yeah. And hopefully I won't boom too much, but I'm going to move a little bit forward so I can actually see what I'm presenting. So, good afternoon. As Nick says, I'm James Widmer. I'm the Chief Exec and also one of the 2 co-founders at a company called Advanced Electric Machines. And not only has Nick asked me to come and... A little bit closer? Is that better? Good, yeah. Not only has Nick asked me to come and talk about the future, which as anyone who reads the news at the moment will know, it's impossible to predict what's going to happen tomorrow, let alone in 2050. But he's also, if you'll see at the end of the presentation, he's stolen my gag as well. And you'll see what I mean when I get to it. So we've been asked to talk a little bit about our businesses, and I'll do that first, and then to move on to the vision for the future. And the two things are connected. So what does Advanced Electric Machines do? So the premise of the business is that when we get into the 2040s, 2050s, we're going to be building something like 100 million or more electric vehicles each and every single year. And we believe that those vehicles should be built using the cleanest possible materials. The challenge is today that the motors that go into electric vehicles, 85% of the vehicles out there use materials called rare earths, which are environmentally unsustainable. They're about half the cost of the electric motor, and they're also subject to real critical supply constraints in the future. So there are forecasts, for example, by the International Energy Authority that suggests that by 2030 there just won't be enough of these materials to go around. So our vision is to do something about that, and we do. And we're not the only people who can take the rare earths out of an electric motor either. But I think our USP and where we differentiate ourselves is not the removal of the magnets, it's the fact that we can remove the magnets and then actually make the resulting electric motor better than the ones that we're replacing. And we talk about faster, further and greener. So faster, we can actually make a more powerful, more compact electric motor than what's possible using these rare earths that 85% of the market use today. Further, we can improve the efficiency of the motors over the drive cycles that electric vehicles use, and therefore increase their range. And we've had customers suggest that compared to our competitors, we could maybe get 10 or even 12% additional range from the vehicle by switching to our technology. And all of that whilst being the most sustainable technology we believe out there on the market. And I talked a bit about the rare earths. The previous slide also talked a little bit about the removal of copper. So we go beyond the rare earths. The removal of copper is all about improving the recyclability of electric motors at the end of their life as well. And that's what makes our technology so uniquely sustainable. And this is, we are an SME, but there are more than 50 of us at the moment. We've been going since 2017. And we have products to market. We have products that serve HGRM 300 at the end, the truck and the bus market. No rare earths, very, very sustainable, very high performance. We're launching a product at the moment which is an air-cooled, by the way, I apologise for the formatting of some of the slides, but we can't actually change anything. It's all locked down. But we have a new air-cooled motor that's coming out, which is half the size of the nearest competing motor, and which has been bought by a fantastically supportive German Tier 1, which they're going to be launching into a vehicle later on this year, and they've ordered in volume. And we're also looking forward to the future, and we're developing these motors also to feature in future passenger cars. At the end of the day, passenger cars are most of the volume, and that's the market where we want to be, because we think that's where we'll make the most difference downstream. And those motors are able to operate at 30,000 revolutions per minute, which is about 2 to 3 times faster than anything which is currently in an electric vehicle today. And this stuff is real. It's out there on the streets. It works. It's proven. We've got a manufacturing facility that can build 12,000 per year. We've got buses and trains and all sorts of vehicles rolling around the world which have done more than 4 million, I should say, kilometres using these motors now, and that's growing day by day. Last time I presented this, which was only at the beginning of the month, it was 3.5 million kilometres. So it gives you a feel for just how quickly we're racking up the miles. So that's an introduction to the business. So then, what about this question, this straightforward question that Nick asked me about, well, where are we going to be in 2050? And the question was about us, but also about the market. So really, I'm just going to repeat some of the slides I've already talked about to start off with. So, as I said, the use of rare earths in 100 million electric vehicles is not sustainable. It's not sustainable because there won't be enough by 2030 to go around. It's not sustainable because it's half the cost of the electric motor. And it's not sustainable because it's environmentally really difficult and unpleasant, and we shouldn't be using it. So I think the solution is going to be by 2050, let's not use these things in electric motors. And the other thing I see is that there's been a lot of talk in the press recently about whether or not electric vehicles are really going to take off, or whether or not your internal combustion engine vehicles are going to come back. And I think my view is that the future is going to be electric, and there's lots and lots of reasons for that. One of which I'll talk about in a moment. But I think it's now inevitable that vehicles will be electric. I think that turning point has been reached, and I think there will be, as there always with change, there will be teething problems and issues with the transition. But I think this is now happening, and that obviously is a big driver in terms of what we hope to be the future for AEM. And that change, that growth, is being driven by a number of factors. In the UK, you see more and more electric vehicles out there. Partly that's due to charging infrastructure, for example, legislation. But actually, I think the thing which people often don't realise, and this is an example of the customer who's using our new product, who's a German company called Saf Holland, who are the biggest axle manufacturer for trucks in Europe. The reason that their customers are switching to electric technology, though, is simply because it saves money, and that's the reason it's inevitable. So if you put electric technology onto commercial vehicles, even passenger cars, if we get the charging infrastructure pricing right, then it's just less expensive to go and drive electric than it is to use petrol or diesel. And particularly when you're looking at running a commercial business, that's an important fact, I think, which is often overlooked. And in terms of AEM, well, as I already told you, we're the best. My vision is, if you've got a good technology and you can get the right support from investors, from people like Innovate UK and from other funders, and also really, really critically, and probably more critically than anything else from customers, then why on earth shouldn't you be successful if you've got a solution which offers the advantages I'm talking about here? So, final slide, and I said I was going to go and have the same gag as Nick. This is we're talking about the future, an AI-generated picture of what it thought that a city would look like in 2050. And the bit I particularly like is that some of the cars are going down the road the wrong way, and the bus is right across the pavement, which I think is normally considered to be less than ideal. But I think putting this in its context, and the reason for mentioning AI is if I look back to when I was going to university, I got to university and I got my first email account at university, and that was not much longer than 25 years ago, and we're looking now 25 years in the future. So the internet, when I went to university, was really in its infancy. AI is now in its infancy. Electrification is actually a little bit further ahead, but still really in its infancy. You're looking at 5% of vehicles on the road in the UK currently being electric. That's due to grow. And so it's very difficult to predict. But what do I think? Well, I think electrification will dominate, and I think if for no other reason than for economics, as demand goes up for commodities, whether they be the magnets I talked about, but actually more oil and gas, I think, in the future. I think people want to move to electric. I also think people like to be able to breathe in cities, which is another big driver for that. I think the world will have to push towards net zero, because I think if not, we're all going to be swimming, which I think is unfortunate. A little bit easier in Newcastle, where I come from, a little bit more difficult, I think, if you're a London resident, maybe. I think also, really interestingly, the world population is going to be approaching its 10 billion peak by then, if you look at the forecasts. It will be up at the top, so I guess that will be maximum number of vehicles on the road, maybe, and then it will be dropping down beyond that. And one assumes, I'm not sure what this has got to do with the market, but perhaps even AI will be starting to get things right by then, all of the time. We have to explain to some of our engineers it's great to use AI, but please check the results before you send them to anybody. That's the important thing. And then what does that mean for AEM as a business? Well, I said more than 100 million electric vehicles per year. I think the best technology has the right to dominate, and I think the one which doesn't use dirty, difficult materials has the right to dominate as well. So I think the future should be bright for us. I think in general, as we develop next generation technologies, we should really be focused on not repeating the mistakes of the past. Lead in petrol was a great example. Let's just not put the lead in the first place. Let's do something different. In the case of our technology, and I think other people can achieve the same things, we just use steel and aluminium. That's all that's in our electric motors, and I think that's something that we really need to be focusing on. Hopefully, we can be a leader in that. And I think the final thing, which is absolutely true, this is my last point. Don't worry, Geraldine. The final thing is, whatever happens, we're going to have dealt with a period of absolutely unprecedented change by 2050. And I said I can't tell you what the world is going to look like next week, let alone in 25 years. But I know it's going to be quite a ride, whatever happens in the lead up to 2050. Thank you.
Thank you, James. As someone from London, not Newcastle, unfortunately, I'm very familiar with buses being halfway across the pavement. Right, absolutely fascinating. Thank you. Without further ado, I shall introduce our next speaker, Doug from Matter. Thank you.
Perfect. Hello, everyone. Let's get through to my lovely face. Oh, gosh. Alrighty. So, I'm Doug. I am one of the co-founders and CEO of Matter, where we're creating industrial AI for factory sentience. Sounds pretty cool, right? So hopefully you enjoy this talk. But first, I want to start with this sort of thought experiment, which I don't think do enough. that everything in this room was manufactured, right? From the chair you're sat on to, okay, apart from you, yeah, apart from us humans, to the light bulbs, to this clicker, to the clothes I'm wearing, thankfully. Everything in the room was manufactured. And unless it's, super bespoke, like an artisanal, piece of designer clothing or chair, it's probably made in a factory, okay? And factories don't really get enough credit. So I suppose I want to start by saying, how many of you have been inside a factory that's producing stuff at scale? Probably this audience will be better come on hands. Oh, it's a pretty good audience. It's pretty good. Some audiences, very few have been in factories, which I think's sad. But for those of you who didn't put your hands up, how is actually everything made? Now, if we were, paying attention to the media or the news, we think of factories as super clean rooms making our GPUs and silicon devices, or maybe jet engines, or perhaps, loads of robots assembling cars or rockets that land themselves. This is what factories and manufacturing is like in 2025, and apparently certainly in 2050. But what about something that we never think about? Something actually that is inside all of those items on the previous page, something far less glamorous, like a steel pipe. How's a steel pipe made? Well, this is actually a photo of one of our partners that actually makes steel pipes. You see it's dirty, it's messy, it's noisy, it's a bit chaotic. It's the opposite of a clean room. And things go wrong, a lot of the time, and it's hard to figure out why they happen. So in this factory, for example, there are people that stare at steel pipes all day. 8 hours a day, 3 shifts. They're looking at a pipe like this to make sure there's no cracks, no scratches or whatever. It's mind-numbingly boring, and they make mistakes. Manual inspection means there are issues that appear. All these mistakes then damage the reputation and profits of the company. They're caught way down the line, which leads to a huge amount of waste and energy usage. And when something's gone wrong, you've got to stop everything, do root cause analysis, say, why did it go wrong? You're normally relying on a bloke called Keith that's worked there for 40 years, who's got deep knowledge to know that that scratch was caused by something here. So this tribal knowledge is super hard to replace. I think the average age of people in manufacturing in sort of the UK is about 52. So absolute nightmare, even a steel pipe, never mind a rocket. And when we've got something wrong, as I mentioned, we've got to do this root cause. We've got to figure out why. Is it poor parameters? Did the machine malfunction? Was it human error? Diagnose it, try and fix it, start manufacturing again. Okay, there's some context. So what do? We build AI foundation models that kind of understand the manufacturing process, why things go wrong, how it happens, so we can fix them. So we take in, you'll see in the top here, sensor data. That could be video, it could be process data, part data. Shove this through our model, our MFM backbone, and then we have various tasks that we can achieve at the end with different products, from detection to correction, prediction. I'll explain these in a sec. So let's start on the first one, detection, which is, I think, the key place to start, because if you can't measure it, you can't make it. We need to know if something's okay to start with. Right, how does this work? Well, we take these models and then can use them to catch pretty much any error in any process in around 24 hours worth of training time. So we'll take an off-the-shelf camera, that's literally a normal webcam you would use for Zoom, strap it onto a manufacturing process, anywhere you want really. We start then collecting data. After about 24 hours of sort of learning what good is, we can then deploy a model onto this camera, and this effectively does sort of smart spot the difference. It's trained to remember what all the good parts it's seen have been, and then if it sees anything that's wrong, like maybe in this one here, there's a little dent in the corner, we can go vudunk, without sort of any crazy supervision. And that means that our customers can then automate their QC, their inspection, generate reports, etc. And hopefully you don't have humans staring at pipes 8 hours a day, 24/7. So let's just see this in action, actually, with a pipe. So here we've got a normal off-the-shelf camera, sort of 100 quid. This is just a pipe, genuine pipe, with some errors on. You might even struggle to see the errors. And in real time, you can just roll it past a camera. That could be by hand, or it could be on a track. And we can immediately pick up any kind of defect. Pretty cool, robust to different lighting conditions, camera position, pipe type, you know, whatever. And we can get super high resolution too. So here's another video of different kinds of pipes up close, where we can even estimate the area, the depth, the size of that scratch. And you'll see a bunch of them here as we swap them in and out. And all of this is done sort of unsupervised. We've just looked at 5 or 6 good pipes and are doing spot the difference for what's the difference between good and bad, in this case, these scratches. And don't worry, I know I've got very excited about pipes, but we can do this across different manufacturing processes. So in process for something like additive manufacturing and 3D printing, to we've worked with inspecting bottles, food and drink, things like crisps, electronics, PCBs. We're working with a company that does the sort of waterproof membrane you put in your rain jacket, where again, they have people that stare at membranes for 8 hours a day. It's mad. So there's a huge range of use cases. Cool. That's step 1. We've learned to like measure things, detect them, inspect them. Great. Now, how do we try and replace that Keith guy where, you know, he had all this tribal knowledge and he knows how to fix the problem once he's seen it? So we want to ultimately do that root cause analysis and then have real-time feedback to correct the issue in the manufacturing process. So on the next slide, I'm about to show you another video. This is actually of a 3D printer, and we've got a video, like a camera mounted on the nozzle of the printer, and we're watching it as it's making a part, and you'll see there's an error that appears. And just from that video, we then predict something's gone wrong, what caused it to go wrong, in this case, pressure, how we can fix it, increase the pressure, and we send a command to the machine all in real time to solve the problem on the fly. Very cool. So here we go. You'll see a problem appears now, boom, and we've sent the command back to fix it, boom. Really cool. All done, not, you know, closed loop by measuring some parameter somewhere, just by watching the output product. And where you can get really sci-fi is you can then say, can we use this maybe to learn how to manufacture with materials we've never used before? So in the next video, we're changing pressure, temperature, speed, all in real time. And you'll see it looks crap at the beginning. And as we go, it's getting better and better and better. And it's kind of doing its own parameter discovery to figure out what steady state is. And now we've sort of done our design of experiments for you all in real time. So this technology is, yeah, already deployed and working. So we've now got detection and, oh, go to the next one. There we go. And correction. And we're rolling this out at the moment across processes and partnering with different OEMs in, you know, different manufacturing types. We've got a company that uses big KUKA robot arms for like welding and stuff. It's very exciting. And where we're at currently. But again, I was asked to sort of talk about the future. In how things are going in the AI space, 2050 is a long way away. So I'm just going to be talking about what our roadmap is instead of the next 6, 7, 8 years. So we think in the next 18 months to 2 years, we'll be able to move one more layer like up the stack to prediction. Oh, we've seen 10,000 pipes go wrong like this before. Maybe before you even make your pipe, you should do this, right? So starting to find those patterns before you make your part. 2, we think in the next 5 years, we'll be able to move into the design phase when you're creating a part. So we believe engineers in 5 years' time, when they're sat designing things in their CAD program, we will be able to flag up to them, by the way, this corner here is too sharp for this material, for this kind of machine. We would recommend designing the part in this way, given all of the previous information and data that we've seen. And by sort of the 7, 8 year mark, we hope to connect all of these stages together to actually do invention. So I genuinely think in the next 10 years, the engineering process will look like someone sitting down, drawing a doodle, writing a specification, and they will have AI to go, vadunk, here's how you should make the part, given everything we've learned about factories at scale across the world. You're like combining the knowledge of millions of engineers and millions of manufacturing hours into one model. So this is super, super exciting. So who knows, 2050, oh, it's going to be mad. It's going to be great. Anyway, this is the path forward. How did we get here? Well, yeah, we're an AI startup based in London. We're a team of AI researchers and manufacturing experts from places like Google X, Microsoft, MIT, Cambridge. And we've got a bunch of sort of publications, patents, and everything behind this technology. We started about 2 years ago or so when we span out of Cambridge and have since raised our first sort of round of VC funding at the beginning of last year, de-risked the tech, came up with ways of deploying it faster, what we call few shot, and closed our first big enterprise contract with some machine OEMs in October. And we're now like deploying out at factories, at scale, and it's super, super exciting. Hiring too, so if you know anyone, that'd be great. And yeah, can't wait for the next few years of this journey. So, that's it. Help us make factories sentient. I was Doug. We're Matter. Thank you, thank you.
Thank you, Doug. So you've seen our beautiful graphic representations of what the future of manufacturing might look like, and given us what the future of manufacturing sounds like in the dunk. So thank you for that. That was great. Right, we move on to our third and final speaker, who particularly want to acknowledge stepping in very last minute. But here to give a third opinion on what the next 25, what the future might look like from a manufacturing perspective. And in this instance, particularly what it looks like when we start working with biology and biotechnology. So Jen, please take the stage.
Thanks. Is this just going to work? No? Okay, it's on there. Oh, what's that? Oh, there we go. I've got a point. Sorry, got a point where? Okay, fine. Cool. So, good afternoon, everyone. Thanks for joining us today. I'm Jen van der Hoeven. I'm the Chief Operating Officer of the Bio-Based and Biodegradable Industries Association. And I was only asked on Friday to do this. So I'm giving a much higher level kind of overview of where biology could take us by 2050. So our journey today is going to take us through the past, present, and future of chemicals and materials. But before we jump in, let's remember that history isn't just about the past. It's a guidebook for the future. And by understanding how we once lived in harmony with nature, we can better predict and plan for a future that works with, not against, our planet's natural systems. So buckle up as we fire up the DeLorean and take a trip back to the biofuture where our past and future collide. So let's set the clock to 1850, and this is before oil. So the world was then powered by nature. Chemicals and materials came from wood, cotton, hemp, flax, and wool. Energy came from biomass, water, and wind. So we lived in a bio-based world, whether we realized it or not. But then came oil, cheap, abundant, and seemingly limitless. Plastics, synthetic fibers, fertilizers, all powered by fossil resources. It seemed like the future had arrived, but little did we know what the consequences of that decision would be. If we fast forward to 2025 today, our planet is feeling the strain of 150 years of fossil dependence. Climate change, plastic pollution, and resource scarcity are the legacy of that decision. The chemicals industries alone emit 2 billion tons of CO2 annually. That's more double that of the aviation industry. And Doc Brown once warned us, you're not thinking fourth dimensionally. And we've been stuck in this linear model of take, make, and throw away, ignoring future impacts. But what if we could go back, not to 1850, but to bio-based principles, using modern science to work with nature and not against it? So let's set the clock to 2050. Imagine a future manufacturing technology that could build a £5 billion industry, create thousands of skilled jobs, and significantly cut greenhouse gas emissions, Well, that opportunity is real, it's here, and it's now. Our joint vision for 2050 must be for the UK to be a leader in developing sustainable chemicals, helping us reach our net zero targets whilst creating a world without waste. So chemicals are in everything that we rely on. They're in our food, clothes, phones, medicines. And while energy can come from sources like wind and solar, chemical production requires carbon as a feedstock. And to maintain these materials and chemicals that we all rely on for modern society, we must use more sustainable inputs. The future must be bio. Alongside a displacement of fossil resources by biomass, by 2050, like I said, waste must be seen as a resource. We need to see waste as a carbon-rich material that can be captured, valorized, and re-entered into the UK economy. And utilizing waste and biotechnology, we can create high-value products from waste materials. And this bio-upcycling approach can shift the chemical industry from a linear model to a circular one. And the key technology that will enable this is engineering biology, which is the nature-inspired reprogramming of biology for industrial use. The flux capacitor, luckily, of bioinnovation is charging. Scientists are using engineering biology to modify microbes to eat waste and produce high-value chemicals and materials like fragrances from fatbergs, medicines from plastic, and textiles from mushrooms. These aren't distant dreams. They're happening right now. And companies adopting these materials are gaining market share as consumers prioritize sustainability. We're at a pivotal midpoint here in 2025, halfway between the millennium and our 2050 net zero commitments. And the next 25 years are critical. Does anyone here remember New Year's Eve 2000? I do, that's showing our age. So if you were there, you remember that the world was braced for a technological meltdown, right? Banks were going to close down, airplanes were going to fall out the sky, all because of the digits changing. But thanks to proactive preparation, the lights stayed on and planes didn't fall out of the air. And Y2K showed us the importance of action before a crisis hits. And this is a lesson that we all need for climate change. So what can we learn from the past? Well, this image up here, published in the Daily Telegraph on the 31st of December 1999, reflects public perceptions about events likely to happen in the next 100 years by 2100. So this poll from a right-leaning publication 25 years ago already placed climate change high on the public's list of concerns. We won't read the rest of them. Some of them have come true, some of them crazy. But what this tells us is that actually we have two core issues. The first is that we've got an action problem. So we know what the stakes are, but we aren't acting fast enough. And the second is a perception problem, that climate change feels like a distant issue rather than a present crisis. We know that the UK has world-class expertise in bio-based chemicals and materials research, positioning us as potential global leaders. But conflicting policies and regulations across government departments hinder their commercialisation. Previous strategies have promised to deliver, but then policy changes have never materialised, and this inaction has got us to where we are today. So what can we do? Well, the pandemic showed us swiftly that how swiftly industry and academia can collaborate. We cut the development of a vaccine from 10 years to 10 months. And we need to apply that same urgency to defossilise our chemicals and materials sector, securing a sustainable and prosperous future, and one that's worth over £500 billion a year revenue for the UK. So what could possibly go wrong? These three words. Drill, baby, drill. So Trump has very much set the clock back to 1850. But as the doc said to Marty, you can't go losing your judgment, and we can't let short-term politics stall our progress. To build a thriving bio-based sector, we need to scale innovation by investing in R&D and scale-up facilities. We need policies to support and align regulations for sustainable materials. We've got to create public and private partnerships to foster collaboration for faster commercialization. And we need to drive consumer awareness and educate people about the benefits of these materials. The next 25 years are our critical window, and we can't afford another Y2K style panic on the eve of 2050. By embracing bio-based chemicals and materials, 2050 can be a milestone and not a deadline. And as the doc would say, the future isn't written, it can be changed. You know that. Anyone can make their future whatever you want it to be. So let's make ours bio-based. Now is the time to act. The future is bio-based, and the countdown to 2050 has begun.
Okay, Jen. If I could invite three panelists to come up. I think we have a little bit of time for some questions. If there are any questions from the floor, we have two people with roving microphones. Have we got a question to get us going? There's one right there. Thank you, sir.
Hello, Doug, this is one for you. And having spent a number of months here staring at surfaces and understanding what went wrong and why, I really appreciate what you were talking about. I mean, one thing that I would like to see probably in one of your iterations, and maybe you will be considering it, is something to also look at it through the lens of perhaps temperature, heat treatments, and other things which are not that visual. So you really have to look at the sort of baking a cake type process where you look at it at the end and say, yeah, this wasn't what I was hoping to see. Maybe something went wrong along the synthesis process, something. So any thoughts on that?
Yeah, no, thank you so much. Totally. So the reason we choose vision at the moment is just it's sort of the biggest catch-all, easiest to deploy across a huge range of processes, right, rather than being super specific. But we 100% have plans in the next sort of 5 years to be rolling out sensing in vibration, acoustics, temperature, and going more multimodal in how we understand these manufacturing processes. There's a bit of that in some of the closed loop control and correction. We use video, but the way that we learn about how that process works is effectively we map, oh, these pixels are changing in a video here, and we've also noticed that maybe the temperature's fluctuating at the same time. Maybe those pixels and temperature, are linked in some way. So definitely keen to add more sensing modalities. And you really highlighted, I think, the super important point is QC at the moment and inspection is always done at the end of the process. And normally something's gone wrong upstream ages ago, and you don't catch it, and then you waste all of the time, energy, etc. in that process. And the idea with our vision systems is to be able to deploy them really, easily and quickly and at a low cost throughout your line, so you can detect things straight away. But totally get for some tasks that it doesn't yet work. Cheers.
Okay, thank you. Question here at the front, Heather. Thank you.
To the first speaker, one of your slides showed a sort of change with heavy goods vehicles towards fuel cells as opposed to other forms. Do you have a view on the sustainability of batteries, particularly for heavy goods vehicles where you have heavier industrial processes?
Again, cost is somewhat, I think, coming to the saviour of the environment in this case, because I'm not a battery expert, but a lot of the early lithium-ion batteries used a lot of cobalt. The cost of cobalt has been a major concern to many businesses building everything from electric cars, I assume, to phones, and also to electric trucks. It's the same. So I think a lot of the technologies that are actually being used are a low cobalt and therefore more sustainable. And in fact, I know some of the companies we've worked with have made a particular point of making sure that was the case. One of the reasons they're choosing our motors is they want their vehicles to be sustainable, and therefore they don't want to spoil that with the battery. Actually, the slide, I didn't really talk about the detail, that the slide actually shows battery electric being by far the winning formula for trucks rather than fuel cell. I guess that that particular consultant thinks that the logistics around the hydrogen infrastructure are difficult to overcome, but it's more driven by BEV than by hydrogen fuel cell.
Okay, thank you. Looking around. Oh, there's a question, the lady over there, if you wouldn't mind, Heather.
Thank you all. Wonderful presentations. This is for Jen. I think as I'm a CEO and founder of a company that does make things with biomaterials, seaweed in particular, but would like to hear more about the initiatives that are going on here in the UK and in the EU, and just what is it that the organization is doing, and how can others get involved in that?
Sure, yeah, great. So the BBIA, we're a trade association for those in the bio-based biochemical sector. We've got 4 key pillars to the work that we do. The first is around influencing, so trying to get better policy and regulatory environment for these materials. The second is around innovating, so we either lead on research projects ourselves or bring consortia together to apply for funding. And then the third and fourth are around communicating and connecting. So we're trying to build a much bigger voice for the bio-based sector in the UK. We have lots of webinars, events, and we're trying to demystify what bio-based materials are and how they can be a benefit to society. We welcome anyone to join us, everyone in here. Please do come to me. I'll give you a membership form. But some of the work we're doing at the moment is we've been working really closely with policymakers to understand what the concerns around moving from fossil to bio-based are. There's the kind of 12 key concerns. I won't go through them right now. But then we're trying to generate evidence to build, to bridge those gaps. And try and enable policymakers to change those regulations, but based on evidence, not just people saying we want. We're actually trying to get that evidence around the economic and environmental benefits of bio-based materials, and we'll be doing that in the next sort of 6 to 12 months. We've also been doing a lot of work with trying to influence the industrial strategy to make sure that chemicals are in there, because without chemicals, we will all be going back to living in caves, because we'll be naked and we won't be able to get drunk. No one wants to be naked and sober. Maybe that's the new tagline. So yeah, we're doing lots of work. That's my vision for 2050. No.
Okay. I think we've got time for one more question. Just gently take the mic from Jen. Sorry.
Well, thank you. Very interesting presentations. I have a question for the AI. How do you incorporate the human factor into the AI transition, considering that manufacturing is one of the main sources of jobs in the UK? So how do you incorporate that?
Totally. Great question. And a question we often think about ourselves. There's this, I think, feeling at the moment that AI is there to replace, labor, right? When we always think about it as a tool to augment people's capabilities. So you have the expert Keith with a ton of tribal knowledge, right? And we're not saying we're going to replace Keith, but currently he can only stare at one pipe at a time. But what if you could empower him to be looking at hundreds of pipes at a time and have cameras flagging up issues where his expertise can be deployed more effectively and at scale, right? So it's just it's like an enabler and a tool to allow engineers and people in factory and operators to, just operate far more efficiently and not have to deal with the really repetitive manual tasks and often dangerous tasks that are involved in manufacturing. Crowdfund for Keith.
I think you're going to make him redundant.
I don't think so.
He can enjoy himself in the cave, Jen. Yeah. Okay. On that slightly scrappy note, I'm afraid that we've run out of time. So I'd like once again to ask everybody in the room to thank our speakers for sharing their visions with us. And thank you all for coming along today, listening and asking questions. And there's a much shorter turnaround between this session and the next session, but if you are interested, the next session in this room will focus on, again, still looking at the future, but particularly from a skills perspective. But thank you very much.
Good afternoon, everybody, and welcome to this panel discussion on scaling with Innovate UK business growth. I am Caroline Elston-Giroux, Scale-Up Director with the Innovate UK business growth team. And for the football fans amongst you, no, it's not that Giroux. As I was preparing for this 4 p.m. slot, it did occur to me that if I was a radio DJ, this would actually be the drive time slot right now. So you would all be on your way home. So our aim is to keep you interested over the next 45 minutes or so. Just pretend you're stuck in traffic and hopefully enjoy. So welcome, everyone. Joining me for this panel discussion are Andrew, CEO of Sustainable Pipeline Solutions, Joe, CEO of Innovate Recycle, and Karen, CEO and co-founder of Oceanium. As you'll hear in this discussion, these three businesses are indeed frontier innovators of materials and manufacturing high flyers. In preparation for this panel over the last couple of weeks, we found that although they are ultimately in quite different sectors, there are plenty of things in common, both in their journeys to date and also with the challenges that they're facing. And I think we've heard a lot about that actually today across this whole event. Commonalities in their growth and scaling journey include the support they've received from Innovate UK and Innovate UK business growth, not only financial support such as grants and loans, but also business support right up to the Scale-Up programme that they are currently benefiting from. And in terms of challenges, we can note raising investment in so-called capital-intensive hardware. And as we'll discuss here, we think there is an opportunity to also see these investment opportunities as capital secure. And I'm sure we'll hear more about this from Joe later on. So as a final thought before we dig deeper, I'd like you to consider this, that I'm privileged to work with ambitious founders and CEOs like Karen, Andrew and Joe every day. Innovate UK products and services do help businesses to grow and scale, and they massively de-risk the offering. These guys and businesses like theirs are the future, and what they're doing can and will shift the dial. This is the real heart of economic growth, of developing new jobs and new kinds of jobs. They are part of the UK's frontier innovation businesses, and achieving their growth and scaling ambitions will certainly help the UK to achieve its own growth ambitions in the future. So I'll kick off this panel by asking each of you to briefly introduce yourselves, and then we'll move on to your 5-minute presentations.
Thank you very much. So I'm Joe, founder and CEO of Innovate Recycle. We are the first carpet recycling facility, unsexy, but we are the first carpet recycling facility in the UK. We take polypropylene carpet, deconstruct the component parts, which is calcium carbonate and latex glue, and polypropylene fibre. We then pelletize or densify the polypropylene fibre to go back into tier 1 automotives. So in the coming years, your new Volvo, Lexus or Jaguar Land Rover will have a body bumper or interior dashboard made of carpet.
I'm Karen Schofield Seal. I'm the CEO and co-founder of Oceanium. And we have a biorefinery technology which breaks down seaweed into component parts, producing multiple end products. So we're seaweed, which is sexy, actually. So yeah, and I've got a presentation. I'll tell you all more about it in a minute.
Andrew Stevenson, I'm founder of Sustainable Pipeline Systems. We've developed the world's first automated and mobile pipeline manufacturing system that introduces a digital nervous system into pipelines, which currently run rather blind. So you'll hear more about it in the presentation in a moment.
Thank you very much. So I think it's important that you get to know each of these businesses a bit better, to have a look under the bonnet and see what they do and how they do it. So I'll hand the floor firstly to you, Joe, and then to Karen, and then Andrew.
There we go. So, Innovate Recycle. Our challenge at this moment in time is there's over 500,000 to 1 million tonnes of carpet waste produced each and every year. It's one of the products that we all use in our own homes, whether it's upstairs or downstairs. It's one of the products that you have to land your feet onto to walk out the door to go to that 9-to-5 job. It's a very underrated textile that is utilised in both commercial and domestic areas, and there's a huge potential to making it from a waste, which is product based, burnt for energy to waste or landfilled, into a resource that can be used, as I alluded to earlier in my introduction, into car body bumpers, interior dashboards, paint trays and pots. Over 80% of all carpet that's produced in the UK and on the continent is polymer based. So that's either nylon 6, PET or polypropylene. The majority tends to be in the UK polypropylene, and Innovate Recycle's solution is to recycle that back into a pellet. The other two outlets for the material so far is landfill, which is reducing quite dramatically. There's about 10 to 12 years of remaining left. We actually landfill 147 million tonnes of material into landfill each year. And incineration, which is still the reliance on burning a fossil fuel, plastic in this case from the carpet. So we take our material through an innovative solution. We deconstruct the carpet at our Northampton plant at a rate of 2.7 tonnes an hour. We glean the polypropylene material back, which you can see at the top, and we pelletize it. We add certain additives to that material to colour or increase or decrease its certain characteristics to meet an end marketplace. Our plan is to replicate this around the UK 8 times. We're looking at doing 20,000 tonnes, circa 20,000 tonnes per plant. Our Northampton facility is on its growth trajectory at the moment, where we're adding more of a scale, so more team members to run the operation 24 hours a day, 5 days a week. And as you can see, it will, over the next 10 years, with 8 plants, generate over 90 million EBITDA. So taking something that is normally either discarded or burnt into the circular economy for the car industry and the injection moulding industry. So we plan to do that with the help of Scale Up programme through regional expansion. So 8 plants around the UK, strategically placed in order to be able to take the lion's share of this material, as well as importing it from abroad as well. We also have market potential, and that will only capture 25% of the marketplace, by the way. So there's still huge amounts of material available for other applications out there. We're looking to recycle 150,000 tonnes of carpet, which will do as around 90,000 tonnes of pellet. If we look at the scale opportunity here, if Volvo were to use 35% recycled content in their car body bumpers and interior dashboard, they would only require 55,000 tonnes. So the 25% of the marketplace wouldn't even barely scratch 2 automotive industries. So huge potential marketplace there for us to go into and generate significant revenues by charging £1,000 to £1,200 a tonne for the pellet. So we've raised 10 million, circa 10 million to date, and over the last 3 years we've managed to get from concept to operation, which is a phenomenal achievement. We are working with the likes of Biffa from waste management to a post-consumer point of view, Cormar Carpets, who are a UK manufacturer of carpet, and Mitsui, as you can well see there, best part of £9 trillion worth of resource. Also as well, we've managed to get to revenue generating, which is an achievement in itself. Now it's time to get to that scalability, more operations on the site as well as scale up. Couldn't have done it without the Scale Up programme. We'll touch on it a little bit more, but I'd like to say a big thank you to Innovate UK and the Scale Up programme, because one of my mantras is you don't know what you don't know, and they've brought a hell of a lot of resource to Innovate Recycle in order for us to streamline our operation and concentrate and focus on the things that are really important to the business and cancel out all the noise. But we'll touch on that later. Thank you.
Yes, thanks, Joe. I got lots of questions. I want to hear more. Yes, so Oceanium, we develop and produce innovative seaweed ingredients for people health and ocean health. We are an impact business, a profit-driven impact business. We are based up in Oban. This is what this is, and I have a 90-second video which does a really nice job of showing you a bit about the team and what we do, the products. That does give you a quick overview of the business. We think that seaweed is the next major crop. Currently, there's 35 million tons that are being processed. There's the potential to go to 98 million tons. 98% of the industry is in Asia. So that leaves all the rest of the world for us to start farming seaweed like they do there. And just quickly, I'm going to run out of time, but farming seaweed is important. It's a regenerative crop. It's not like taking wild kelp forests up, which they do in certain countries here in Europe. They don't do it here in the UK, but in other countries. So we really need to get the seaweed farming industry going. And it's a massive market with potential to grow to 33 billion by 2030. And this is from a World Bank report that was done with Hatch Blue. And we are playing in that area up there in the white, that 7 billion market opportunity with new emerging applications, not your traditional hydrocolloids or straight to plate, but with nutraceuticals, high value, human and pet food, materials and inks. And it's important that it is this high value products because we need to pay a good price to the farmers so that they can scale up. So really need to maximize the value of the seaweed, and that's what we do. And I think we're the only ones that are doing it at the scale that needs to be done at. This is a quick snapshot from that same World Bank report, which shows, again, where the market opportunity is. The nutraceuticals is where we're focusing. Again, very high value. We're doing clinical trials, doing the regulatory, all that hard work, laying the groundwork for this foundation to grow the industry. We very much have an international vision. Our plan is to build our first facility, ideally here in the UK, our first commercial facilities. We've proven the technology at scale. And we're ready to go. We've got the IP, we've got the regulatory, we've got the markets, strong commercial traction, engineering design by a global player. So we're going to build our first facility and then replicate and scale, ideally in partnership with local regions who want to grow their seaweed industries. Alaska is really ready for it. Other parts of Europe and North America that are keen. Just in terms of materials, because we are at a materials and manufacturing show, is our ocean ink, and I actually have some samples I'll pull out in a minute. But we have developed an ink which can be screen printable. We are looking for a development partner to take that to mass market, to litho, flexo, digital printing. But all natural seaweed ink, and that's the natural color, is the beautiful gold, is the natural color of the ink, but we can also do black. Yeah, a bit more about the ink. We've got a fantastic group of supporters. World Wildlife Fund is actually have an impact fund. It's one of our biggest investors, Builders Vision, BDT, MSD. So investors from the US, Asia, and UK and Europe. And this, I'll just finish on this.
Most important question, Sarah,
It is the
that I
most
need to
important
ask
question.
you is, what on earth is your obsession with seaweed all about? Why have you got a fixation on seaweed?
Through Earthshot, I've suddenly realised how important seaweed is. It sequesters carbon. So when I say sequester, it draws down carbon. It cleans the oceans, so it has a natural cleansing process. It takes pollutants and toxics out of the water, and you can make things from it. And in 2022, one of our finalists, Nopla, which stands for Not Plastic.
I remember Nopla.
And they created effectively plastic everything, but through seaweed.
From seaweed. It's amazing that once you kind of scratch the surface of all of this, one thing that comes from the next comes from the next, like
That's
a whole network.
The key is to create a circular economy. And if you can create a circular economy where what you're using comes naturally from the environment and can go back into the environment, then suddenly it starts to come together quite nicely. So it's not about...
I'll stop there. You get the idea. So it is, yeah, I'm done. And yeah, so that's Oceania. Thank you.
What we've developed at Sustainable Pipeline Systems is the world's first mobile, automated, intelligent pipe manufacturing system. And one of the things to note is that pipelines are and will remain incredibly important for energy distribution. It's still true that something like 70% of the UK's energy comes from gas pipelines. And whether you have methane, biomethane, or hydrogen, you're still going to need pipelines, and you will need replacement pipelines and new pipelines. So there's been talk today at various sessions about localization of manufacturing technology. Well, there also needs to be localization of energy production and distribution. And that's exactly what renewables open up. And that means that you need new networks of pipelines to make that happen. So the reason we're in this sector is because this is triggering a massive change in where pipelines are needed. And we estimate that there's going to be, over the next couple of decades, 100,000 kilometres worldwide of new pipelines needing to be constructed. That's a huge market. At £2 million per kilometre, that's a huge market. So, and we believe our technology will disrupt that market. The way pipelines are made at the moment hasn't really changed for 90 years. It's extremely manual, based on skilled manual labour, which is now in short supply. It's based on very large numbers of truck movements, moving things from one factory to another and then to the site. And it has also safety issues because the pipelines, many cases, the pipeline operators don't even know where the pipelines are, never mind what their condition is. How do we solve these problems? Well, we have three areas where we're providing solutions to this problem. One is we have a new composition in terms of the pipe structure that enables the pipe itself to be more flexible, to incorporate optical fibre and provide a digital nervous system. That provides an asset management approach with a massive amount of more data, and it also reduces the carbon footprint by 75%, and there's a huge cost saving. So there are a large number of benefits to this approach. As to the material composition, what we have is the Masset pipe on the left incorporates a polymer liner together with high-strength steel developed in collaboration with Swedish steel, optical fibre, and outer layers of protection. This is a much better solution than conventional pipe, which is just a solid steel that is girth welded together and has a number of issues. This enables the pipe to be produced in a continuous fashion rather than girth welded in sections. This is a photograph from our trial site in North Yorkshire. And the digital nervous system has a dashboard, and this we bring artificial intelligence to use to sort of square the circle and interpret the threats during the lifetime of the pipe. So that gives us the opportunity for recurring revenue. On our journey with, through the TRL stages, we've benefited from grants from Innovate UK, a loan from Innovate UK, and the scale-up team, which are incredibly helpful in trying to join up the dots, which otherwise is rather a bit of a random process. We've now got some traction in industry with sales contracts from Scotia Gas Networks, and we're in a consortium with Nordian Energy to help develop a network for the Swedish program, which will include a fertilizer plant using hydrogen as well as the wind farm production. So our value proposition is about reducing the cost of pipelines, increasing the safety, and providing an extra margin. And we're working through our qualification program together with Scotia Gas Network. So it's important to, on this journey, to find a large corporate partner that you can work with in order to get traction in the industry. We have a very strong international patent portfolio. We have an international team that's used to large-scale pipeline projects internationally. And we're currently raising some funds for our Series A round, so we're beginning to talk again to investors. So thank you very much. I think that's about all there's time for.
I've got one. I'm good, thank you. So thanks very much for showing us your shop windows. We come to sort of the Q&A section of our panel discussion now as well. So I've got a few questions for our panel, and then we'll be opening up to the floor with the roving mics for the last sort of 5 or 10 minutes. So my first question for all of you is around Innovate UK business growth support. As we've seen in your presentations, the growth and scaling journey is a long, winding and challenging road. Could you tell us a little bit more about the range of support you've received from Innovate UK over the years up to your time now on the Scale Up programme, and how this support has helped you overcome some key challenges? Who'd like to kick us off?
So when we were first initiated to the Scale Up programme, one of the things that I was reminded of very early on is you don't know what you don't know. And it makes it very clear to me that you've got to ask for the help. The directors at the Scale Up programme are always on call. So if you hit a certain challenge, there's a director that's internal to the growth programme that can help you. Some of our key challenges that we faced at Innovate Recycle was man versus machine. Machine only does what a man tells it to do or a person tells it to do. So what we had to really look at was how we put our job description out there, how we make sure that we hold our employees to account on KPIs, making sure that they're producing the products that we need to on a timely basis within spec. And all of that came from a back-end process point of view. When I first joined the programme, I thought it'd be more about helping with the process and how the mechanics work. Actually, that came relatively naturally and easily with the senior management team that we've got who built the process. The bit that we sort of slightly overlooked in the early years of Innovate was trying to get new employees onboarded with Innovate, get the mission and vision over to them very clearly, and also hold them accountable for their job roles within the organisation and then perform as well. And that's something that the growth programme has really helped us with by defining exactly what needed to be done and when by the individual in that particular role.
Good to know, I have to say. We wouldn't be here without Innovate UK. When I first just decided that I was going to dedicate my life to seaweed, after researching what type of business I could start that would have the most impact, and I did a lot of research and I came across seaweed, and it has all those benefits that we talked about, but I didn't know anything about seaweed. It was actually Knowledge Transfer Network who introduced me to my co-founder. And I see Sally Beacon back there. And she was one of the very first people who was just so supportive in the, I mean, I called up KTN and said, you know, I want to start a seaweed company. What, you know, who can I talk to? And that's how it all started. And then we got our first funding from Innovate UK, coupled with Sky Ocean Ventures. And that, you know, was the start. We didn't have any money of our own, so that's how we got started. And that was actually on materials. And since then, we've had other grants. We've got one going right now, which is looking at our food product, and we're doing application work with Reading University. We've done further grants with the scale-up of the materials as well. So it's been we established the company in 2018. We got the first funding from Sky and IUK in 2019. And here we are later, you know, raised a significant amount of money with great partners, and we've got products that are ready for market. We just signed an agreement yesterday for a distribution agreement for our hero products. Yeah, and yeah, we literally wouldn't be here without them. And we've just joined the Scale Up program. Caroline and the team, Jim Doherty, they've just been fantastic. I mean, you really feel, I want to hug them every time I see them because it's so hard raising money, and it's so, the Scale Up is, everything is so difficult, especially given the externalities and, you know, the funding market and things now. But to know that they're there and got your back and are providing the support on many levels is really just, it's a great thing. So I look forward to the next 5 years. Yeah.
Thank you. And Andre?
So we actually started with some input from Scottish Enterprise and then went on to a grant from Innovate UK, which helped us with our computer simulation phase. And then we had a series of grants that enabled us to build our prototype. We then had a loan from the Innovate Loan Group that enabled us to set up the demonstration site. And without the demonstration site, we would not have been able to get gas network companies to bring anyone to see what we were doing. And unless you get people on your site, in your plant, they just don't appreciate it. So you've got to get to the point where you've got a credible plant and you've got something credible to demonstrate, I think. And then I think the scale-up team are really good because they join the dots. What happens when you apply for a grant, it's a bit of a random process. It's a lot of work to fill the forms, score the right scores, you know, et cetera, but the scale-up team does provide that joined-up approach, and we've benefited from, we reviewed our patent attorney position, we've done a patent audit to improve that, and then introductions to investors, I think, are also an important part of the program. But I think it's the joined-up nature of it, as you were saying, Jen, the fact that they're kind of on call, that if you've got a problem, you've got someone to talk to that's got a very wide range of contacts. So, yeah. So you've got your
Thank you very much. I'm blushing, and I'll take that pat on the back. That's quite nice. But the question that I always am asking myself and our colleagues as well is what more could be done? What more can we do to sort of continue joining those dots? And I think there's a couple of ideas as well that we've discussed around that. And I think, Andrew, notably, you had an idea for the sort of linking in with the R&D tax credit side, if I can ask you about.
So I think that the way government works, of course, is in complete silos, and that creates problems for everybody. I mean, we've had a recent problem with our R&D tax credit claim because the HMRC have suddenly decided to take 10 times longer to process applications. So one of the issues with that is that they don't know what is new technology and what isn't new technology, and it seems sensible for Innovate UK to have some kind of certification system that here we all are, Innovate UK, put a lot of money into this event, all trying to promote growth, and you've got HMRC doing its best to stop it. So if you had a certification system just to say, well, these are companies that have been supported by government funding through Innovate UK, then that would help HMRC triage their process. That's just one thing. Another way, I think, again, it's kind of outreach, I suppose, from an Innovate UK viewpoint, but in terms of investor contacts, I think that could be somewhat more organised in some ways. I mean, there has been an investor session today downstairs, but it's a little bit random, and I know there are concerns about regulatory issues with FCA and so on, but they're really rather artificial. Because all the investors are market counterparties if they're organised investment firms. So I think there could be a more organised approach to investor introductions somehow.
Elaborating on that, we managed to get some money, 2.35 million, from the Getting Building Fund back in Boris Johnson's premiership. And what that really accelerated was the private equity money to come over. So without committing, we run a pro forma to the money, and then it was on the basis that we would get the other matched funding up to the 5 million that we required. What it actually did was accelerate that private equity funding. It allowed the due diligence to be done by a government organisation, the SEMLEP in this case, the South East Midlands Local Enterprise Partnership, which doesn't exist anymore. They did a lot of due diligence through a third party that they installed, which then gave confidence to investors. So that then brought the investors over the line, and within a matter of a month, we'd raised 1.775 million off the back of winning that award. So again, it's that link up between sort of private and public money, because the private want to see that the public purses are going to put the effort in, and the risk as well. It's not all on the private's dime, so to speak, and that really does help. So that little bit more of a link in between sort of private and public money, and the commitment for the public money is really vital, I think.
Yeah, I would agree wholeheartedly with both of that. I think also to expand on it even further, again, the first funding we got was public-private, and I think that's a fantastic model, as you say, because it does de-risk it. And spreading that risk is really important. What we're doing with needing to build facilities, people don't want to fund CapEx; they want a fast return, and it's unrealistic. And nowadays, they want revenue when you don't have a facility. But so it's the public and private, and I think that's great, but I think also get the commercial, if there's opportunities to get companies involved as well that could do offtake agreements that say, yes, if you produce this product to this spec, I will buy it. And then maybe philanthropic as well, to get some philanthropic. There's a lot of big foundations out there. So if there's a way to bring them all together, but the commercial does bring a lot of value in terms of the offtake in our situation. But I think also what Andrew was saying about the joined up, because we are based in, we had the R&D facility in Oban, but we also have a team here in London. And so I think it's, all the different entities being joined up. It's a bit of an Easter egg hunt right now to go and figure out where are their pots of funding, because it's dispersed quite a bit. And that takes a huge amount of time and bandwidth, which startups don't have.
Thank you. Some really interesting insights there. For my next question, I wanted to look at the sort of growth and scaling journey, but also linked to investment readiness. and the sort of challenges and giant leaps that you need to make also in terms of technology. So all of your businesses are frontier innovations, as we've seen, involving large-scale demonstrators, first-of-a-kind production plants, or even infrastructure play. So could you tell me a little bit about the challenges you're facing here with your, and also gaining momentum for Series A?
So where we are is that we have proven the technology at scale. We have consistently produced high quality, high purity product to the spec that we're looking to do. We've got the regulatory. We're targeting the US for our nutraceutical products and the EU for our cosmetic ingredients. And so we've got the regulatory, we've got the IP, we've got the engineering design complete by GEA, which is a German engineering company. We've identified buildings, and we're ready to go. And we are raising our Series A, and we're coming to the end of that, which is good. But that is the challenge, is because the funding of capex is something that a lot of the investors shy away from. So I think that the challenge is finding facilities to do scale up. We've worked with different places, Aberystwyth in Wales, and at Reese Heath College and other places like that to do some of the scale-up activity. But then it comes to a point where you're at, where there's not facilities that are big enough to do what you need to do. And so you need to build, and accessing the funding for that is a challenge. But yeah, I think I don't think we could be any more investor ready. That's my opinion. But yeah, that's where we are right now. So, and the challenge is the funding, which we've talked again about earlier. We were talking about the investor partnerships program, which Innovate UK is looking forward to hearing what's happening with that.
In Innovate Recycle's case, we've done a lot of the rounds on the sort of the investment market, and we've spoken to a lot of startup companies, and we all sort of hit the same sort of challenges when it comes to scale, is that you're a nobody until you're a somebody. So what I mean by that is that we occupy a 94,000 square foot building, but yet we're a startup company with no credit rating. Who's going to give us a 94,000 square foot building? Who's going to let us sign a £2 million electricity contract? Who's going to allow us to have offtake contracts from councils, particular councils, really risk averse, literally sort of will not touch you unless you've got 3 years worth of operating data, your health and safety is all in place, which it should be, but then your welfare. So from a scale-up point of view, it's not just about the actual technology itself. That's sometimes the easiest bit because you can answer the questions because you've gone through that learning process. It's about being welcomed into the outside commercial world, property vendors or councils trying to give you a little bit of rate relief. It's a very difficult thing, let alone the fact of trying to secure good talent as well. That's quite difficult in a startup mode. Most people are looking for job security, especially in the economic times that we're finding at the moment. So job security and high salaries have an impact on that as well. So I think what I'm trying to demonstrate is that it's not just one single thing that will hinder growth. You have to look at death by 1,000 cuts. And you've spoken about bandwidth within management. It takes a lot of time just to do the day-to-day stuff, let alone having to look at that sort of future-proofing of how you get to the next plant, raise the money. We're looking at Scotland for zero waste, so they're looking to put some equity in, as well as grant money. But then we've got to then secure more funding from from private investors, and that would be 3 times the amount that we raised initially, so 15 odd million. So you've got to then have all your ducks in a row, and you've got to make sure that you can hit those certain markers. So there are stepping stones that you have to go through, and sometimes time isn't on your side.
Yeah, so in addition to that, we're in a heavily regulated market, and we can't even put a product into the market unless we have regulatory approval from, a gas network operator and ultimately Ofgem. So that whole regulatory journey is fraught with difficulties as well, unless you have a large corporate partner. So a bit of our breakthrough has actually been to get some traction from one of the gas network companies, because it's not only the fact that they will provide some early sales revenue by placing contracts, which are a step forward from grants because they're 100% funded, they allow you to get some small amount of profit if you can, But it's really the hand-holding on the regulatory journey, because unless you're working with, in our case, a licensed gas operating company, you can never get regulated to have a product on the market. But fortunately, the UK is very widely respected internationally. So the consortium we're working with in Sweden is saying, well, we'll join the UK regulatory approach once you get approved. So it's potentially a bit like a very sharp J-curve that once you've got approval and you're on the market, you can see a lot more is going to happen. So I think that is a huge challenge as well as the other challenges of funding and so on. But it is worthwhile because it's a good sense of achievement once you've got there. So.
Still got one. Thank you.
Still got one.
I've just got one final sort of quick question for you guys, and I think you were keen to open up to the floor as well. So at the moment, obviously, you're starting off as UK headquartered businesses. What steps have you made towards going international to date, and what are your plans for conquering the world in the future?
Well, I think that I've taken part in two of Innovate's global business initiatives. One was in Australia, where I managed to meet a number of pipeline operating companies in Australia and see what was going on there in an organised manner, and an even more valuable one in Germany, where they have a huge network of hydrogen pipelines planned for their industrial centre. So I think what we would plan to do is set up demonstration facilities in each country where we want to operate. And we've got a consortium project in Sweden. I mean, it is a global business, and the UK can be seen as the inventive heart of that if it can take the step to this scale-up stage, because the world does look to the UK very often to be the most highly innovative country, but we're just not very good at getting to that commercial stage where other countries can say, well, yes, we'll do that as well. And then you can branch out into other countries. So yes, we would have the ambition to operate globally, and pipelines are needed. I think India alone has planned 30,000 kilometres of new pipelines. They also look to the UK for regulatory and new technology.
I think we've only got a few minutes left, so if you want to...
Quick.
Yes.
Yes. So I think for me, it's about having that vision. The difficulty bit is people pigeonhole themselves at the micro level, happy owner-operator. If you want to set your sights on international globalization, whatever it is, you've got to think big. I get told this by my mentors all the time, and the scale-up program. If you're going to think small, you're going to act small. So you're going to think low-key, you're going to think tomorrow, you're going to think, how do I get through today? The term blue sky thinking isn't the best terminology to use here, but you have got to think about the future and how you're going to hit that, because unless you can see it in your mind's eye and you're reaching towards it, you'll always be on the caution of fear of what happens if, and scale your ambitions back. So you've got to have your tomorrow plan, but then also have your 5-year plan and your 10-year plan. I think it's where most of it comes from within business. So your 5-year plan, your medium-term plan, where do you want to be in 5 years' time, and what goals are you going to put in place to get to that point? So for me to go sort of the internationalisation is, right, where's the next country that's got the most carpet, or where's the next region that has the most carpet or produces it? How do I get there? How do I knock down the barriers? So it's about having that mind's eye about the next site, the site after the site after, which will allow you to grow and not have this sort of almost caged thought process where it's just going to be one plant and then we'll see how it grows organically over the years. You have to really force the effort.
So we want to help the world. So, from the very beginning, we've had international plans. And it really comes down to our mission of ocean health and people health. And we really do feel that seaweed is going to be hugely important for food security, given drought conditions, soil erosion, all these other things, water, freshwater access, et cetera. So it's super important that we start seaweed farming all around the world where it's suitable and grow this industry in a sustainable and managed way. And we unlock the industry because we are producing these high-value products, again, to pay the farmers. So we're focusing on, in terms of internationals, again, we're focusing on sale of the nutraceuticals, our hero ingredient in the U.S. And we have established relationships with farmers in North America. Again, Alaska is really keen to grow their industry. The Northeast and up in Maine, they're really keen to grow their industry as well as the Nordics. They see seaweed as the new species of aquaculture. So. Yeah, and then I very much want to get to Asia and to Africa. It was actually a story called Sex, Seaweed, and Liberation, which was one of the impetuses because of seaweed farmers in those parts of the world in Asia and Africa are women. And I have a very strong gender lens on what we're doing. So that's our plan. And there's other solutions that we bring to Asia, for example, because they have a bit of a monoculture. But we can valorize other species so the farmers can start farming other species and get higher value for that. So, yeah, it's very much a big picture play, big vision.
So we could probably throw open for a question, maybe two, if we're quick. Has anyone got any questions for our panelists? Thank you.
There's a lot of talk, and there's been a lot of talk for many years about the fact that the UK and also Europe as a whole is just not putting enough money up for scaling world-beating technologies, and that therefore most of those ultimately disappear to the USA. How do you see that? Do you subscribe to that view, or do you think that in your business that's not necessary?
Very topical. Who's going to take this on for a whistle-stop 30-second in a nutshell response?
I knew anecdotally, I do know of a few businesses that have gone to Europe because they do get the funding there, and some countries are very bullish and very aggressive on offering a lot of grants and a lot of funding. So yeah, so there is that, and. But I think working with the Scale Up program and the help that they're providing, it will help us grow here first and then take the technology abroad. But yeah, you definitely see attraction, people courting you from other locations. Yeah.
For me, I think we need to look over the pond to America on how they do deals. Risk is just eaten for breakfast. I think there's a different relationship with money over in America as well. You're sort of investing in your future. So I think the relationship over sort of on the continent in the UK needs to change to more of a US type. I've been over there and I've seen multi-million-pound deals done at the pub while watching the football game. Over here it's completely different. It's suit, tie, pitch, hundreds of people in a room and probably get one taker. And it's all about that risk analysis that people take. And I think if we want to enter into the growth stage within the UK and Europe as well in that matter, I think we have to really focus on, okay, that there is going to be a possibility that I lose my money on this one. However, let's look at the fact that this could really scale. And I think our three companies are testament to that. Well, my counterparts are very more innovative than I recycle carpet. However, it's a very simple business model that can be got on board with. And now at that Series A growth stage, it's about taking that leap of faith, putting the money into an organisation that has proven so many and knocked down so many barriers over the last several years, and then having that conviction to get to that next stage. And I think that all starts with the investors having a different mindset. It's not to say that they're right or wrong. It's about the risk analysis that they may look at, and having to tick that box of, are you revenue generating? If you don't quite meet all of them, it's a no. Sometimes it may just need you to look into the grey areas and say, okay, possibly we'll take a punt on this one. It might not be the full ticket size, but we'll have a little bit to help you and see where you go.
The simple answer to your question is yes.
Oh, gosh, that was...
Was that short enough for you, Carol?
I'm glad I was sitting
there's
down.
generally 5 times more capital at every stage in the United States, particularly California and Texas. So you've got 5 times more capital at every single stage. And that's why they have so many more large success stories.
That's brilliant. And I think to close out, there was a quote from this morning that really resonated with me. It was Catherine Bennett, who's the CEO of the value manufacturing catapult. And she said that at this stage, the biggest risk is taking no risk at all. And I think for you guys, it definitely speaks volumes. So I'd like to thank you all for sharing your insights. Thank you all for your time, and enjoy the closeout of the event.